Ladies and gentlemen, we ask that you pay attention for a few minutes to watch the following security video. The object of this video is to organize a possible evacuation in case of an emergency. The evacuation teams of the Palacio Municipal will act accordingly to control any type of emergency that could occur. The evacuation order will be received through the loudspeakers. The access to the auditorium is done through the main hall of the building. The front doors will be open for the access and exit of all guests at the event. In case of an emergency, all the glass doors in the main hall will be opened. Likewise, all the front doors of the auditorium, on the sides of the building marked as emergency exits, the doors on the sides of the first row of seats, the marble staircase exit, the complementary areas, and the emergency exit stairs that end at the platform will also be opened. Security staff will be in the center of the auditorium and at the front of the stage guiding guests in order to organize the exit. Once the order has been given, stay calm. Follow at all times the instructions given by the emergency team staff. They will be identified by wearing a reflective vest. Do not return to gather personal objects. Walk at a fast pace without running. Do not use the elevators. After exiting the building, if you notice the absence of a companion, inform the building personnel and follow their instructions. We inform you of the existence of medical assistance at your disposal in case of it being required. Don't hesitate to contact the security staff. In case of an evacuation, go to one of the following 3 meeting points. 1. Avenida Capital de España and Via de Dublin. 2. Calle Ribera del Sena and Glorieta de Su Alteza Real Don Juan de Borbón. 3. Calle Ribera del Sena and Calle Strasburgo. Thank you very much for your attention. We kindly request that you keep your mobile phones off or muted. Welcome to our greenhouse, where the future of connectivity comes to take root, grow, and flourish. Welcome to Fyuz. Communication, innovation, networking, connectivity. Are you ready to harvest some new ideas with us? We start to grow in 3, 2, 1. Make it bloom. Welcome to Fyuz.
For the first panel of the day, continuing disaggregation of hardware and software, Chipsets perspective, please welcome Francisco Martin Pignatelli, Group Head of Open RAN at Vodafone.
Good morning. Good morning, everybody. There are many things you could be doing in Madrid today. There are many things that you could be doing in the summit. It's been a great event, but you are here today. So thank you very much for your attention. I also need to thank our sponsors for making this possible, and we are also hoping that you post what you see in social media. This is going to be a very good panel. I think it's the best panel of the event, and main reason is the topic. Chips are really important. They are at the center of our radio. They are very relevant when you look at the cost. They drive most of the cost. They are also very important in terms of performance, and there is a lot of discussions about matching performance between Open RAN and traditional radio. So they are really important, and we've been talking about that a lot. There's been a lot of media conversations about that, but today, and this is also the main reason, the quality of our panelists. We have the most relevant guys in the industry talking about chips today, And I'm not going to delay too much the start of the panel, and I'm going to be welcoming Christina from Intel, Punch from ARM, Joel, Marvel, and also Dino from Qualcomm. So welcome. Let's start. Good. Hi guys. Okay, so first, let's talk a bit about the overall context of Open RAN. It's been a journey. I think we've made a lot of progress. We're starting to see products in the field. We're starting to say it's good quality. But obviously, there's still some way to go, right? Some things to do. So I want to start asking everybody, and we'll start with Christina here, about your views about who needs to step up now. What is really, where do we need to really focus as an industry? Is it suppliers? Is it the operators? Someone else? So what needs to happen for this to be successful? And I tell you, it's going to be successful. It's only how fast we do it. Christina, please tell me.
Great question to start with, Paco. I think that definitely will get us going. Absolutely, it's a journey. I totally agree with you, we have made a lot of progress. You guys at Vodafone, fantastic results and fantastic progress. It is, as we have always said, it is a collaboration, it's a work, it takes a whole industry to come together and do this. So you say, who needs to step up? Everybody. I think we are past the proof, right? We're past is this the right thing to do? Is this going to give us the best outcome for the operators? I think we're past that point. Everybody, the technology is ready. The results are demonstrating that this is the right thing to do and that we can achieve uncompromised KPIs. So now it's about scaling. It's about going out and getting it done and working together and deploying. It's about deploying at a scale all over the world.
Thank you, Christina. Dino, what's your view?
I agree with what Christina said. So if you compare where we were a couple of years ago, we have made enormous progress. An ecosystem is coalescing around Open RAN. A few years ago, there was some doubts cast on the transition to Open RAN. Some players they were more reluctant than others. Now we're seeing that changing. I see broader adoption moving forward in the roadmaps of different vendors, different players. So I think maturity level also has been improving tremendously. So it's really the time now to put forward some aggressive plans from operators to transition to Open RAN. So
you're pointing at us.
Actually, yes. If you ask who should step up, I think now that many of the questions have been answered, legitimate questions. Can we have really quality equipment at these uncompromised KPIs Christian was saying? Now we do have, I think we do have line of sight, an ecosystem of vendors. I think the broader ecosystem of vendors, maturity of equipment. We do have line of sight in the next 1 or 2 years to have really a very thriving ecosystem. So it's really now, I think it would be really operators to now step up and make aggressive plans to do the transition. So if you are asking me.
Thank you. We at Vodafone, we are planning for the tender that will offer for competition the entire radio network. That will happen very soon, so I hope that
excellent.
We'll address this point.
Here you go.
Yeah,
perfect.
Yeah, good. Pans, what do you think?
Yeah, so Christina and Dina have made some good points, so I generally agree with that from an ecosystem perspective. I think things are coalescing well. When it comes to broader adoption and scaling, I mean, we look at the different components of the ecosystem, whether it's silicon, hardware, the CAS vendors, the RAN vendors. Everybody looks at each other and goes like, okay, where's the money going to come from, right? So and I have to agree with Dino that it really points back to operators, and we really appreciate the initiative that Vodafone has done, we hope that other operators follow suit and scale from there. I'm sure we'll talk about the scalability aspects and how to close the gaps or perceived gaps that exist today, but we'll save that for a little later in the conversation.
Thank you. Joel?
I think that an objective metric for progress is revenue. And by that metric, we haven't made much progress. Sorry, guys. I do think that we've learned a lot. I think that we've developed capabilities. I don't think that we are at a stage that we see results quite yet. In order to get there, in my opinion, some of the system vendors have got to step up and think what it would take. If you look at the radio access network today, it is based on custom appliances. Those custom appliances are designed to operate outdoors without active cooling, with passive cooling. They are designed for maximum reliability and availability. If we want to succeed to move that to a server environment, we really need to think what a vRAN server looks like. It's got to offer similar things. It's got to either be able to operate outdoors, or if you put it in a shroud, it's got to be able to operate there without active cooling. It's got to be able to offer similar type of reliability and scalability. And those things are not there today. We can absolutely experiment with things, but to scale them on the same scale as the traditional RAN, we're not there today.
Okay, I think we will be exploring at this point a bit further in the conversation. So, okay, yes, operators, we need to step up. That's one of the takeaways. I think also it's important when you start discussing commercially and setting up new processes that dealing with the multi-vendor ecosystem, we need to set up how we do it as an operator. We need to have the right processes. We need to be able to talk to several suppliers at once. So the commercial maturity of Open RAN is one of the areas where, beyond just the product, I also think we need to work further. And that obviously on top of system integration, which are things that we are already well underway. But yeah, we'll get there. I think we need to also learn by doing. And when you start doing your processes, your commercial processes, you adjust, and then eventually we will find the new way of doing things. But yeah, today we are talking about chips, and we in Vodafone we've been pushing a lot in this area as well. We set up our R&D center in Malaga, and we have announced in the event our collaboration with Intel. I hope you didn't miss that one. We are going to be taking the algorithms and the ideas that we develop into physical chips manufactured. But okay, it's already 10 minutes. And there is an elephant in the room. The room is very big, but there is an elephant. And the elephant is the architectures that we are seeing for level 1. So I want to get into that now so that we don't delay the topic much more. So we've been hearing about inline architectures, look aside. Obviously, we have a good representation of the different views here today. And I would like to start this time asking Dino first, if you can explain a little bit the two options, the main differences. Where do you see advantages and disadvantages? And yeah, we remove the elephant from the room, or we clarify a few points. I will also ask all of you about this. It's an important point, so we capture what everybody's thinking. But yeah, please, Dino, tell us, what's your view?
So as a Qualcomm, one of the things we are doing as a contribution to the ecosystem is, of course, try to optimize and make it as efficient as possible the compute for the baseband, for the Open RAN architecture. We are doing also work on the radio unit, but I think your question is more on the baseband computing, so the layer 1, which is the heavier, the elephant to be processed in a way. So, because again, we believe in this vision that Open RAN and vRAN, they're not a zero-sum game. They're bringing big benefits on the table when they can really bring down cost, also bring lower energy consumption for an operator. So we try to really come out with an architecture for computing that can really optimize these metrics. And the way we found the most optimal way to optimize computing was to make sure that the entire L1 is passed through an accelerator. So because we thought that was the most efficient and most power efficient and cost efficient way of doing that. So we have created an SoC that does exact that. It can process the entire L1 to produce, again, the most impressive results we believe, in the computing of the baseband for Open RAN systems.
Okay, so that's one of the options.
So this is what you refer to inline. So it's really offloading the entire L1 to an accelerator. So running the entire L1, especially for massive MIMO, high throughput, low latency systems through an accelerator, as opposed to running mostly on the CPU.
Thank you. So I think I will ask now Cristina, who's probably best person to talk about the other alternative. So Cristina.
And how much time do we have? About an hour?
I think this topic, we need to close it forever now, so we can stay for a couple of minutes probably.
Okay. So in that, aligned with that, to close the topic, we have been, the industry maybe a year ago or more than a year ago, got into this debate between inline and look aside. And the history of that is because we have been in this journey for a very long time. And the majority, as we all know, the majority, if not the vast majority of all vRAN deployment and Open RAN deployment is happening today with Intel Xeon architecture and server architecture. And the way we started was that one of the acceleration of the workload, specifically for the forward error correction, we had it on an external card. And we did first with FPGA, and then we did with a more advanced technology ASIC. And that's why the industry got the look-aside term versus having an acceleration card. That's old. So we continue talking about that, but we'll move away from that. We've just been in this journey for a while, and we have been the evolution of the technology happening. Today, we have, with our 4th generation of Intel Xeon Scalable processor with vRAN Boost, we have all the acceleration, including the forward error correction, everything that you need to process the RAN workload, we have it on the CPU, fully integrated, on die, memory sharing. There's no look aside there. It's completely fully integrated. So we have moved that, and that's the future. We'll continue evolving that path. But that's what you get today with the Sapphire Rapid E. That's the code name, or the 4th generation with vRAN Boost. I think it's important. What I like about our architecture, I think what is important is that, number one, you can run the entire workload in our CPUs, number one. Number two, you don't need any external acceleration, and by doing that, you are reducing the complexity of the design, but you're also saving power consumption. For example, with the 4th generation with vRAN Boost, we can double the capacity and reduce 20% of power consumption from the previous generation. It's more than double the performance per watt. So it's significant what we're bringing. But in addition to that, I think what is important also that by having layer 1 virtualized, so we're talking about software-defined network, virtualization all the way to layer 1, by doing that, you can do things that you couldn't do if you have a proprietary SoC in a PCI card. You are able to do, as an example, the amount of, say, algorithm and intelligent algorithm using AI, for example, that you can do for your channel estimation and channel prediction and bin management. Just the amount of things that you can do, and this is just one example, wouldn't be the same. And that's an additional advantage. The design, the complexity reduction, the power consumption reduction, and then the innovation, the amount of innovation that you can bring, including AI, when you have a fully virtualized, open kind of network.
So you're saying that there is a benefit of having multiple functions, including AI, all together. In one place.
You got it.
There is one of the claims of inline architecture is about the scalability and the fact that you can have your baseband with PCIe cards, and whenever you need more capacity, then in theory you can add more, and you don't need to go for an entire server. What would you say about that? So scalability and capacity.
Yeah, we have high confidence that the workload, the needs of the workloads today can be addressed for the most part with one server. And it is a matter of designing the right way, optimizing the software and running it, and using the acceleration and the ISA extensions that we have. And we are absolutely convinced that that's the way to go, and there's no need again for having acceleration, additional PCI cards, consuming power and adding complexity to the design.
Mm-hmm. Okay, thank you. Once, so back to the original question of inline versus local side and your view of advantages, disadvantages.
See, I'm a big believer in software-defined everything, right? So, and that shouldn't be a surprising stance coming from a CPU vendor, right? So, but let's step back and look at the problems we are actually trying to solve here, right? So, Joel alluded to it earlier. Can we do it air-cooled instead of additional cooling mechanisms that consume electricity? Paco, you really care about your OpEx when it comes to power efficiency. And so we really need to think about what is the most effective way to manage TCO, right? And so, and that directly has a proportionality to how you manage power, right? And so if you look at the amount of compute requirements for layer one, I mean, I'm not sure how many of you have seen the chart that Ericsson has put out in terms of layer one compute requirements. As the capacity increases, the compute requirements almost like jumps up exponentially. And so you really have to think about what's the best compute mechanism to process layer one, right? Is it CPU-based? Is it accelerated? Or is it a combination of the two, right? And so looking at the compute requirements and the power requirements around L1 today, for the foreseeable future, our stance is you need like an inline type of an accelerator coming. We may evolve as the compute power efficiencies and the right CPU architectures come into play, but that's inline is probably the best way to manage power, which maybe you have opinions on this, right? So which will directly correlate to how operators generally make a call on the gap between traditional classical RAN versus the virtualized RAN. How do you close the TCO and efficiency gaps that we are trying to close now?
Good, thank you. Joel?
So anyone who is still thinking about Lucas side, I would suggest that one of you pick up and consider starting a startup. Just think about it. There are billions of Ethernet PHY chips over there. So maybe instead of buying an Ethernet PHY chip, you can build an FPGA, put it on a PCIe card, and run the Ethernet software on the server. I think that's going to be a real problem, and obviously no one is going to consider anything like that, so I'm not 100% sure why we are considering an architecture like that for 5G. It absolutely makes no sense. So there's no doubt in my mind, or I don't think anyone who is looking at the physics of it, that the inline acceleration is the only way to go. And furthermore, I want to congratulate Intel for joining that decision, what Christina just said. So I hope that with that we can bury the Lucaside concept for once and for all, because I really believe that it's purely a distraction for the industry. Let me add to that. Christina just said the concept of the VRAM boost is to bring it into the server chip. I think that first of all, again, congratulations for Intel for joining the optimized chip for the particular workload. That's exactly what needs to happen. So now you've got choices. You can go with Qualcomm, Intel, Marvell. Each one of them is a unique and different chip to run the 5G protocol stack. These are the choices that we have, and each one of them is optimized to run that workload. And by the way, I do agree with Christina that PCIe is certainly a way to build the system. And I mentioned earlier, we need to think in terms of a system and how we construct that. PCIe is absolutely a way to do that. Another way to do that is to use all kind of advanced packaging that all the different chip companies are able to do. And essentially what Christina was just describing is a way to take two chiplets and put them together in a package and make them into a single, at least from the outside, it looks like a single chip that has both capabilities, and the industry is doing that today on a very large scale in many different applications, and 5G is absolutely a place where we can take advantage of this advanced packaging. There are many other ways to take advantage of advanced packaging, for example, incorporating optics directly onto the package such that the fan-out toward the radios can come directly optics instead of Ethernet. So there are many ways of taking advantage of these technologies.
I think because we are 3-1, I'm gonna say something else.
Please.
So first of all, thank you for the congratulations. We absolutely appreciate that. We absolutely continue innovating in our roadmap, and it will be getting better and better and better, and it will be harder and harder for you guys to catch up. But it was good for you guys to be in the race. It's good for the ecosystem. But again, yes, every generation of our Xeon processor will get better and better. I think, and you were saying who would use that architecture? Well, who's using that architecture? Verizon deploying more than 10,000 virtualized cell sites in the US, Vodafone in the UK, and many others. So absolutely, I think the operators and the community and the industry is realizing the flexibility, the scalability. You were talking earlier, Joel, about scalability. Are we ready? Yes, we're ready. 10,000 in the US or more cell site. So I think that's we're very proud of that, of the scalability and flexibility that you get when you have a server architecture as opposed to having a proprietary, more fixed function kind of solution. I think the problem I see, or one of the problems I see with not running everything on the CPU, you kind of get into, what we're trying to solve with Open RAN and vRAN, we wanted to lower the barrier of entry. We wanted to open the ecosystem. We want bringing every software developer to innovate and to do software and to, the sky's the limit and bring all that brilliance. But to do that, you have to have an open platform. You have to have a platform that everybody knows. So if you take layer 1 now and you put it in a chip that is proprietary with proprietary tools, with proprietary capabilities and configuration, then you are kind of not giving all the opportunities to that ecosystem. You are like, say, okay, you can innovate, but you can only innovate from layer 2 and above. That is just constrain ourselves, where our approach is, hey, you can innovate everything. You can have deep telemetry into the chip that will tell you what kind of power consumption you're having and take actions against that. Hey, you can know where your channels are and you can have a better spectrum optimization. And when you look at that from the RAM point of view, when you realize, okay, this is the way to go because you get the maximum flexibility and the maximum possibilities of innovation.
And
So,
if I may add,
I need to clarify one thing, because maybe for us it's maybe clear, but maybe for the audience. So I think it's true what Christina said before, that I think the look-aside versus inline is kind of an old archaic terminology, maybe a bit confusing, but still there is an inherent difference between the approaches, and maybe we call it a bit still inline look-aside, but just for the audience. So it's really about whether you want to run most of the L1 in the CPU with some accelerator now integrated in the CPU, or you want to run the entire L1 on an accelerator. Still that difference exists. And now, to the point Christina mentioned right now, so we do see, obviously, the point that we want to make sure that it's open for innovation. So, of course, we are working with a new crop of vendors that they benefit from having Qualcomm layer 1 in the card, and they don't want to modify it. But some of the vendors, the more sophisticated vendors, that they want to modify their layer 1. They want to modify some functions. We provide APIs to do their innovation on channel estimation, beamforming, massive MIMO. So it is important that that capability is there. So it's not a static monolithic block, take it or leave it. And but still, again, the big difference still exists on whether you really want to run the entire layer 1, especially for higher order systems, higher order MIMO systems in an accelerator versus in the CPU with some selected accelerators for forward error corrections, also a few other functions. So that still stays the difference. Then the rest has been evolving, of course.
Okay, so there is some room for innovation, you say?
Of course, yes.
There's always room for innovation. I think we are confusing the industry, and I'm not sure why we are doing it. Fundamentally, when we look at a chip to run L1, we're looking at some general purpose processors. Qualcomm, Marvell are using ARM-based cores. Intel is using an x86-based cores. So we're looking at a processor, and next to it, we're putting accelerators. And these accelerators are unique to 5G. I'm sure Christina would tell you that vRAN Boost is designed to run 5G. It wasn't designed to run your ERP system. So these are dedicated, unique accelerators. Each company developed them differently and uniquely and trying to do the best job we can. But fundamentally, an L1 chip is a set of standard processing cores next to accelerators. That's how every chip company does that. And these differences that we are talking about now are about how to put the system together, not about how to put the chip together.
Joel, you know who else does that? The custom RAN, the traditional equipment. That's what they do. They create, of course, they use CPU, they use cores, but what they create is a specific purpose for the RAN SoC, and that's what they're doing. But that's the traditional RAN, the custom RAN, purpose-built, whatever you want to call it. But that's exactly what we're trying to avoid. If you open the Open RAN web page, the ORAN web page, the first thing that you read is, we want to run our workloads in general purpose processors, right? And that's what we're trying to do. We're giving the world a general purpose processor where you can run completely in software your workload. But the other options, your option is to have this. Yeah, you can do all that from layer 2 and above, but in layer 1, we're going to have all these proprietary engines working together with acceleration that nobody knows what is going on there.
That's right.
Right?
And vRAN Boost is one of those unique custom optics.
Yeah,
right?
it's like doing custom, but calling it something different.
So the point is again, these are standard processors. Yes, Intel call x86 standard, but we call ARM also standard, okay? So this is a standard processor next to unique accelerators, and Christina is absolutely right. These things are used in the traditional RAN, and they will also be used in a server-based ORAN, vRAN, Cloud RAN type deployments. From the chip perspective, It's the same thing. This is why a company like Nokia can use the exact same chip in both the traditional and as part of their PCIe card inside a server. This is exactly the reason they can use the exact same chip, the exact same software.
Yeah, can I add to this? Like, this is not really a religious war, right? So it is, I guess Christina and ARM, we come from like somewhat opposite ends of the spectrum when it comes to like completely general purpose, and ARM has historically been pretty closely tied to heterogeneous computing with accelerators, right? So, and as ARM is moving more towards general purpose, Christina seems to be moving more towards adding accelerators into the mix. So it's like at some point we'll meet somewhere, right? So I think it talks a little bit about the future of computing, which if we have time, we'll talk about that, right? But this is not really a religious war, right? So it's really looking at what problem are we trying to solve. In this case, Paco, you brought up L1 processing, where the processing compute requirements are going through the roof as the capacity increases, especially going into massive MIMO. How do you effectively solve that problem? Is it a CPU-based, which we would love for it to be? ARM makes extremely power-efficient CPUs and plays really well there, right? But it has to be accelerated, right? So eventually it does become a heterogeneous compute model, and to Joel's point, we need to step back and look at it from a system design perspective.
Right. But the thing there, so a couple of things. The number one, again, we're going back to, we have a solution that is working now, right? And you guys keep talking about massive MIMO. The deployment that Verizon did is absolutely C-band, it's massive MIMO. More than 10,000 on the way to 25,000 or whatever it is, the number in the, of deployments, right? So there's no doubt that we can address that capacity. Work that Vodafone is doing, also massive MIMO. So let's not confuse things here. I think, and I agree that I agree one thing that you said, at least one, the heterogeneous aspect of the workload. That is very true. The RAN workload is a high demanding heterogeneous workload. You have signal processing, you have packet processing, you have bit processing. What's the best way to deal with all that is an architecture based on, you can do that in a general purpose processor. That's what it does. That's the beauty of it, that we are able to build an architecture that can deal with all those different types of processing with that heterogeneous characteristic of the workload. And if you can do that and have it in the general purpose processor, it really doesn't get any better. You don't need any external component. You have the RAN space is going to have requirements as far as performance per watt and as far as performance and power consumption. So, we are able to do that with a general purpose processor and a server architecture that gives you the maximum flexibility and scalability, and you can do everything in software. It doesn't really get any better than that.
I agree with that, except you need to worry about power consumption.
Yeah. Of course, it's part of the RAN, and we've been doing this for a very long time, and we could have been, or the operators couldn't have been deployed if the metrics wouldn't be there. But it's absolutely an aspect, and we're very happy with the results.
Again, we are playing with words. General purpose compute has a place. Every one of us is using it, either in the form of x86 or in the form of an ARM instruction set architecture. So absolutely, it's necessary. But the accelerators are not exactly general purpose compute, regardless of whether you take a chiplet and you connect them with the CPU. It doesn't make them into a general purpose compute. And that's a good thing, because general purpose compute stopped evolving in terms of performance about 20 years ago. Nowadays, as you can see in the hyperscaler environment, every time that they have a workload that they fully understand, the processing of the workload, the data structure of the workload, they offload it to something else, to a dedicated chip. You see that with the Nitro of AWS to run the TCP/IP stack. You see that with the Google TPU to run the machine learning inference. You see that with machine learning training chips. Every time we understand the workload, we understand its data structure, we offload it to a dedicated chip, call it accelerator. The same thing here. We are using a general purpose compute. We all do, either ARM or x86. And in addition to that, we add unique accelerators for 5G because they're necessary, because 5G compute complexity is increasing by an order of magnitude every generation. And that is not something that a general purpose compute, regardless of its ARM or Intel, can catch up with. Moore's law ended about 20 years ago.
Joel, I give you a data point so you have a few facts with you. Since we started the vRAN journey, three generations ago of processors, we have been double the capacity generation over generation in the last 3 years. And of course, we're going to continue investing in our roadmap and making sure that continues. So I think the compute has advanced, absolutely. Moore's law is very much alive. I don't think that is slowing down anytime soon. If anything, it will be continue, leading the world. But yeah, that's a little bit of fact, so you know. This is proof. I'm not even talking about the future that it hasn't been proved. I'm telling you, proof, and what does he say? The proof is in the pudding. For the last 3 years, double the capacity, generation over generation, unquestionable.
I'm going to agree with Christina here.
There you go.
Good. Right, in terms.
By the end, if we do this 2 more hours, you will all end up agreeing with me.
Okay. We'll see about that. But in terms of evolution of compute, really, right? So what's becoming increasingly clear, whether it's in a cellular infrastructure kind of an environment or a data center environment, how do you pack maximum amount of compute in a given power envelope, right? So just over the last, you said Moore's law died 20 years ago, right? So in terms of compute evolution, now we are looking at packing close to 300 CPU cores in the same envelope that we did with traditional implementations, right? So the amount of compute we were able to pack in a power envelope has absolutely gone through the roof. And add to that vector and matrix extensions, the compute paradigm has significantly changed.
The reason the world is moving to accelerated compute is because there is a limit to how much you can shove in a square millimeter. You can add in more and more and more compute, but at some point, the power density, how many watts per square millimeter, is going up. And there's a limit to that, because the chip will burn at some point. And that's why the world is moving to accelerated compute. Again, utilizing standard commercial CPUs, ARM or x86, in addition to those accelerators. That's the way of the world.
For us, as operator, it's really important, the energy bill. So also having just one box on the side, if possible. What else can we do from the energy saving perspective? This is an area where we still...
Go with ARM.
What is coming? What can we do?
I think I would say looking into the future, but it's actually not the future, it's the present. We can start doing that now. Applying artificial intelligence to power management, I think it will be very powerful, or powerful to reduce power. We have, and I'll give you a data point there too. We had we did a work with you guys and a few other partners, Capgemini, Keysight, Radisys, and Vodafone, and we saw a significant reduction in power when we use artificial intelligence applied to power management. We did another work with Ericsson, also 20% of reduction in power consumption, using a capability that we have in our CPUs. It's called the C-states. It's basically the capability to put cores to sleep, which anybody can do, but what not anybody can do is the fact that you can bring this course back from dormancy at a very, very low latency. So we have this capability available today. We need to put it to work and deploy it and see the results immediately.
Very good. We're about to close, so I want to go with a final question. There's been a heated debate starting in the morning. I see some degree of convergence in ideas, and I like that. So a question to end on a positive note from this frenemies discussion is how can we collaborate? What can we do as an industry to go further, to progress? Joel, please, 30 seconds.
So guys, I think it's absolutely important to understand that we are all collaborating extremely closely. When we put a PCIe card with our chip on it, and it needs to work in an Intel server, and something doesn't work, we work together, very, very, very closely together to make it work. When we talk about chiplets, you will see in the industry chiplets that are integrating solutions from different companies. So we are collaborating with the rest of the industry very closely, and I love Christina.
Fyuz.
Yeah, so I echo Joel's sentiments. Collaboration is extremely important, and we do collaborate across the board. Looking ahead, I think the collaboration has to encompass the individual layers of the network, right? Whether it's software vendors, RAN vendors, chip vendors, even amongst ourselves, towards solving a clearly defined problem of scalable networks that are very software defined.
Thank you. Dean.
Same here. So I think collaboration is important. And I think Joel made a good clarification. It's not like we do work ourselves with CPUs from Intel, and our system do integrate with CPU Intel or CPU from ARM. So no problem there. We also, our additional contribution to collaboration for making Open RAN system more performing is also, we also have our orchestration layer we provide to operators that tries to align the different components. That is also a nice contribution we can bring, not only on the SoC, but also, and by the way, going back to your previous question, we are also working on the radio unit. We didn't touch about, we ran out of time because, of course, we were talking about power on the baseband, but most of the power is consumed on the radio unit anyway. So there we are bringing also innovation there, but that will for another debate, I guess.
Thank you. Christina.
No, Paco, definitely. This conversation makes us better, right? We're here in a heated discussion, but this is really good. This is good for the industry, makes us, each of us, better. And this is an important part of the industry and the world, and we need to have the best solutions. And we share our learnings, we compare things, and we go back to the whiteboard and build something that's better than what was done before. It definitely makes us innovate more and make us better. So absolutely, this is fantastic. We all need to work together, and Joel and I are fantastic friends, and we love to be in panels together. So it's all good. It's fantastic.
Thank you. So just one remark from me. I mean, if there is a place where we all end up need to converge in for openness, that's the ORAN Alliance. So there's going to be a lot of work in Working Group 6 to come up with new ways of doing openness in this area. So we'll talk about that there. And let me finish by thank you again for the conversation. Thank you everybody in the audience. Thank you everybody online. We have a lot of online attendance this time. And I hope you enjoy the rest of the day and the rest of the event. Thank you very much. Thank you, guys.
For the next panel, RAN Intelligence, please welcome Patrick Lopez, founder and CEO at Core Analysis.
Good morning. Good morning, everyone. Wow, it's been a while since I've been here on this stage. Last time was different name, was the TIP Forum. At that time, we were looking at introducing a new connectivity platform, a new connectivity technology that gave birth to Open RAN. Today, we've seen that Open RAN has grown tremendously, but the promises of 5G still haven't been fully fulfilled. The promise of 5G was that you were going to need different connectivity products for different devices, different verticals, different geographies. And by and large, that yet has not been delivered. Having said that, we understand that in order to do that, there are a number of things that need to happen. And slicing, for instance, is one of the important technologies that need to emerge in order to be able to create those connectivity products. One important part of this is to be able to have a network that is observable, that is programmable. And the next frontier to achieve that is in the RAN. It's specifically the RIC and the apps that are going to be developed in order to allow the network to basically be optimized and to be observable in real time. So today, we have a great panel of specialists that are going to join me here on stage. And we're going to discuss the promise of RIC and its apps. So I'd like to call the panelists to join in. Ashish, Steven, Matti, Konstantin, and Andrew, please. All right. Thank you. As we're getting seated, I will ask each of you to introduce yourself briefly before we start the panel. Well, your name, your title, and what is the interest of your company in RIC and apps. Thank you.
Thank you. Hi, I'm Ashish Yadav. I'm Head of Technical Product Marketing and Partnership Alliances for Software Frameworks at Capgemini. Capgemini makes RIC frameworks, XApps, RApps, and we help our partners or customers to create their own RIC, white label it, and help them with all the XApps and RApps that they need. Thank you.
I'm Andrew Thiessen. I work for the MITRE Corporation, which operates a number of federally funded research and development centers on behalf of the US government. And I manage all of the 5G Next G work inside the company. I think in particular, I mean, I think you've heard from the US government, you know, Amanda Toman earlier this week, right, about the NTA Innovation Fund when it comes to ORAN. So there's a lot of interest in supply chain diversity. And certainly, you know, all the government customers that we work with are interested in the same, and so using things like the RIC.
Thank you.
I'm Matti Hiltunen from AT&T. I'm a lead inventive scientist there. I'm the RIC SME at AT&T. I've been working on the near real-time RIC since it was kind of invented. Jointly worked with Nokia to build the OSC open source RIC platform. Then I acted as the PTL on the RIC app project for a couple of years, and then since then I've been working on ORAN and TIP. Nowadays I'm looking, kind of making the business case for the near real-time RIC and looking for interesting XApp and RApp ideas.
And I'm Konstantin Polychronopoulos with Juniper Networks. I'm responsible for the radio intelligent controller as one important station towards delivering the promise of 5G by means of network slicing, right? There's no network slicing without the radio intelligent controller. And Juniper is a unique place to work because it brings all the domain assets together. So we are trying to stitch the last mile together.
My name is Steven Spellisy. I lead marketing and business development for VMware's service provider and edge business. Our telco cloud platform and our portfolio enable operators to modernize their infrastructure, and as a big part of that is the introduction of our RAN intelligent controller product, which is enabling both optimization and monetization use cases to transform the RAN.
Thank you. Okay, let's get started. Let's get started about the RIC, and I guess the question is, why do we need the RIC? What is the RIC going to provide that goes above and beyond today's RAN capabilities? And maybe what do we see from TIP in terms of the use cases and the development of the RIC itself going forward? Maybe we can start with Marty and
sure. I will start with the TIP question first. I'm a member of the TIP RIA operator group for the last almost a year. I have some inside information on how it works. And I've been very happy with it. What TIP has done is develop use cases, requirements for those use cases, and then found vendors and teamed up vendors like XApp vendors, platform vendors, simulator vendors to evaluate these use cases. So I think this is very valuable because for us as an operator, all these use cases are exciting, but it's just simply too expensive to evaluate them ourselves. And so for the what kind of use cases and what kind of applications would be relevant, of course, different organizations like TIP and ORAN and others have done vendors, operator surveys and found out what use cases are being ranked highly, and there's, of course, energy saving, traffic steering, massive MIMO. But the general characteristics of what I think should be looked at and how it should be evaluated would be the use case has to have value. The value could be either improving the network, for example, spectral efficiency, or reduce the cost. For example, energy saving is the simple one there, but automation, especially in the R apps, or the use case should enable new business cases or revenue sources. So those are the kind of business cases that we get excited. And then the evaluation, it would be very important to kind of, when you evaluate a use case, be able to say, how much does this use case improve from the baseline? And not only evaluate an XApp in isolation, but think of, okay, what if we implement this use case using an R app? What is the benefit over the baseline? And what additional benefit does an XApp give? And then for the evaluation itself, of course, this is a big ask, but it should be scaled enough, like in our own experiments. Sometimes we do trials and then we present the results to the RAN organization, and they say, well, it looks good, but we have had experience that when you do a small trial, you may see good results, but when you scale it out, the benefits reduce.
Yeah, we'll look at the testing and the scaling in a few minutes. Andrew?
Yeah, I mean, so we've heard throughout the week, right, that it seems like there's thematically two primary things that ORAN is going after. One is operators are looking at it to try to decrease the total cost of ownership of their network, right? Where can I save money, whether it's through power efficiency, better traffic management, what have you. And I think that's obviously important, but I mean, you know, the elephant in the room is that, you know, 3GPP also standardized vRAN to try to do the same thing. So it's not like ORAN is the only solution to try to get after OA and M savings. And so to me, the more interesting piece, right, is the new business, right, you know, trying to get inside new wallets with new money, right, because I don't think anybody's paying more for a 5G subscription on their handset today. And so where are the new industry verticals? And my favorite one, my go-to, is industrial automation. And I think what the RIC will do, combined, you know, we're now seeing kind of the inflection point where a bunch of technologies are getting to the point where they're mature. You know, edge compute, you know, the insertion of AI ML right into that edge compute, along with the RIC and a near real-time control, we might be able to actually see something beyond the EMBB networks that are being built today, where the RIC with MEC might actually enable massive machine type comms or URLLC, right? The other sides of what 5G was supposed to deliver, and I think that's where those new business cases are actually going to come from.
Yeah, and I guess, sorry, I'm going to reiterate part of the question, which is, what does RIC bring that is not possible with traditional RAN vendors?
Well, I mean, the control of the system, right? I mean,
yeah.
So I think somebody said earlier this week that the RIC is basically like the RAN operating system.
Mm-hmm.
You know, right now, you know, if I go buy a G-Node B from an incumbent manufacturer, I don't get to rewrite the scheduler,
yeah.
Right? And so if I have some use case that has a particular set of needs beyond enhanced mobile broadband, I can't modify how the RAN works to actually enable those use cases, right? I get that with the RIC, right? With the exposed E2, right? And the you know, so X apps and R apps actually enable me to do that.
Thanks.
Guilty as charged. when it comes to the RIC being the operating system. I've been parroting that for a long time. It is indeed. RIC is the operating system of the radio, right? That's the way we should look at it. I want to address the question in a qualitative way, right? I think we all agree that to deliver the promise of Industry 4.0, to go to smart infrastructure, smart 5G, 6G, etc., the radio has to be adaptive, agile, dynamically managed. I think we agree on that. We don't have that today. We also agree that we need a host of applications to leverage the power of the radio access, right? There is a long list of applications that operators have been asking for. Obviously, applications that address TCO, energy efficiency, quality of service, massive MIMO, beamforming, and on and on and on, right? And more applications will come across. You cannot have applications clamoring for access to the radio without having an arbitrator that will decide how these applications are going to access the resources, reconfigure things in order, right, etc. Otherwise, you have chaos. You cannot get any optimization. The RIC is what provides the solution for both. From south going north, from the radio components, DU, CU, RU, and from the application north going south. This is why the RIC is the operating system. We call it the operating system of the RAN.
Thank you. Yes?
I would say, to add to that, the extraction of intelligence above and beyond what we know as the RAN today. I think the data is very captive inside the vertical solution, right? So we're disaggregating the intelligence layer from the RAN. And we're also opening that up to not only access specific types of data, but also share data across the RAN. And I think the enrichment of that data between X apps and R apps are going to enable new and wonderful use cases that can help operators not only improve the operation of the RAN, but also increase monetization. And I look beyond the usual suspects, the ones that we talk about, traffic steering and radio performance optimization, which are all essential, very important things. But I think as we move forward, things like location awareness and services, understanding RF security, these are dimensions that we have yet to explore, which create new opportunities for the operators and the vendor community.
Thank you. So I have an opinion. I have many opinions. I'm French, but sometimes contradictory. But anyways, I have an opinion that is unpopular. There's the non-real-time RIC and the near real-time RIC. And the non-real-time RIC, I mean, it's evident in the sense that, it's basically the fusion or the evolution of SON, OSS, EMS systems. These are mature elements, and they're ripe for disruption, really. And they're easy to disrupt for new vendors that are not necessarily RAN vendors, right? The near real-time RIC, it's a different beast, really. It's part of the RAN elements, and I mean, it's embedded today within RUs and CUs and DUs, and it's part of the fabric of the Open RAN. And well, Open RAN is not yet fully mature, so I don't know that it's ready for disruption. For the whole RAP and XApp ecosystem to work, you need the non-real-time RIC and the near real-time RIC. What's the maturity level, really, of vendors in that space, in the CU-DU space, to basically implement the interfaces that are necessary for this implementation? You want to start, Ashish?
Sure. So let's divide this into two parts. One is the RAN part, and one is the radio part. The common answer is, it's not where it's supposed to be for both, but it's better for the RAN part than for the radio part. There are some big names that are behind, that are coming in now, that'll open up the interfaces, and it'll make the O1 interface more towards the RAN. The smaller players they make the back of the tail, I would say. So they will follow once the bigger
have implemented it.
Heavy incumbents come in and open those interfaces. They're there for very common use cases. If you talk about E2, if you talk about network slicing or traffic steering, these kind of cases, they're there. But if you talk about near real-time rig, the applications there, they have less open interfaces. There are still proprietary things there. How can the vendors help? Try to keep the implementation such that when these interfaces do become open, which from all it seems from Fyuz announcements is coming soon, you should be modular enough to take it in quickly. That's what we are doing at Capgemini.
Yeah, thank you.
But otherwise, it's still, the radio part needs a lot of work. RAN part, we are getting there.
I was doing radios until recently, and I mean, the scheduler is the crown jewel, right? I mean, you rarely touch it. You certainly don't let other people touch it.
Exactly. Right? It's so guarded. It's like Z-class security.
Yeah. I know you have strong opinions as well.
I do, Patrick. In your question, I think was embedded the question of do we need both, right? Near real time and non-real time, in addition to the maturity question?
That's part of it,
right.
For sure.
We absolutely need both, right? Because the near real time rig reacts, works with the radio, addresses part of the, radio infrastructure, a number of macro cells or, 100 micro cells, whatever. I can use an analogy, for example, we all can relate to the memory subsystem, right? How caches work, several layers of caches work with the main memory, right? You need the cache to access very quickly certain data, and you go periodically to the memory. It's, sort of loose analogy, right? Or think of the operating system and the device drivers. They are not used all the time. So, when it comes to the maturity, I think the Oran Alliance has done a fabulous job pushing the specifications. I think the specifications have reached the level of maturity where major NEPs can definitely move on with implementation. We've been working with a number of radio vendors, and we see significant progress towards supporting E2, O1, E2, both AP and NSM. But if you look at the big NEPs, we still have a ways to go, right? But I keep saying it's a one-way avenue. There's no way you cannot, go with evolution.
I think the participation is there at the standardization layer. I mean, all the vendors, the software ISVs, the CUD vendors are all at the table to work to mature these interfaces. But I think that's one aspect of it. The other aspect is the maturity of the market from the perspective of implementing these technologies. You have a large number of disruptors on the CUDU side who've started to bring this technology to market. You have a vast group of ISVs, legacy SON vendors who are transforming into RF vendors. You have disruptors in the XApp space. So I think there's a lot of enthusiasm in the market, but what we see is the balance of the implementation today is on the smaller vendors. We'll call them the disruptors. And the incumbents are late to the game. So as that balance shifts from the disruptor to the incumbent, that inflection point happens. I think this is where we see the maturity of those standards change into implementation and into true adoption. So all of these people can take advantage of those capabilities.
And you said, go ahead.
My concern is, for example, for a non-real-time rig, you have applications like energy efficiency. Everybody's running towards that.
Yes.
But it's not standard, and of course we can do all we can to ensure that it's modular, but we're not there yet, especially for non-real time.
Well, and you said that the incumbents are late to the game. I mean, that's by design.
Yes.
Right. I mean, the non-real-time RIC is interesting, but it's the least threatening thing to incumbent business models. And so, I mean, that's why, it's much easier for me to go buy something that has a more mature non-real-time RIC than I can certainly do anything in the near real-time space.
Mm-hmm. Yeah, and in some cases, I mean, incumbents are not especially strong on the OSS part, so it's actually an opportunity for them to claim to be Open RAN and do something about Open RAN without risking their core business, right?
Let me put it this way. Non-real-time RIC is less invasive.
Yeah.
When you go to near real-time, you really need to open up. And that's where everybody's having problems right now.
I had a comment to the first question, actually, that I want to make about the benefits of the near real-time rig and non-real-time rig. It makes the RAN much more nimble. Like right now, if we want some feature in our RAN, we have to wait for our vendors to implement that. And maybe we're the only ones that want that feature, so they have to prioritize us, our specific ask with some things that many customers are asking. So with the near real-time rig, XApps, RApps, it may be possible to implement this feature by having somebody else build the XApp. And for this second question, I agree with all the panelists that the different vendors are in different stages of the E2, especially adoption. But what I'm hoping is that we'll see some really successful use cases with the more nimble vendors, and that will force the others to adapt it.
So obviously, for rig to be successful, I mean, rigs are platforms, right? So you need apps, maybe many apps, definitely apps from different vendors. And right now, because it's still very early, do we have really the right fabric of labs and interoperability facilities that would allow app developers to really be able to implement their apps against like as close to real data sets as possible? Because at the end of the day, most of those apps rely on some machine learning algorithm, and that only works if the data set that they're operating upon is as close to real as possible. I don't know, want to take?
Yeah, I mean, you know, labs are interesting, especially, you know, over the last couple of years. It's like the big shiny object. Everybody has to have a laboratory, right? Whether it's a government, a company, right? I mean, you know, the proliferation of OTICs, and for full disclosure, you know, certainly my company has applied to become an OTIC. You know, but everybody wants to be one, right? Because if you don't have a lab, you know, you don't have much of a say if you're not actually making the products. You know, I think that, you know, we've had a successful model, right, when it comes to telecom, you know, with the way we look at interoperability between UEs and the GNOD B, right, based on RAN 5 conformance tests and 3GPP, right? You know, operators go to PTCRB or GCF and say, these are the conformance tests that you must run, right, in order to be interoperable. I mean, I think the one thing that we talk a lot about is interoperability.
Yes.
And, you know, I was in a group yesterday where we were talking, and I think interoperability is certainly important. And I don't exactly know the math, but really when we're looking at ORAN, it's like an n squared minus n over 2 problem, right, for interoperability. So it's not a scalable model to actually do interoperability testing. And what I haven't seen is the same level of maturity in, you know, in conformance test specs for the ORAN Alliance, you know, reference points. And, you know, and so there's a bunch of chicken and egg problems. We know we need super dense and mature conformance test specs. You know, the test equipment manufacturers then have to be able to implement those things. Then when you do conformity tests, because it's really about conformity tests for me, it's not about interoperability, you get about an 85% certainty if you can pass all the conformance tests that you will at least be interoperable, you know, with whatever you're trying to hook it up to. So I think, you know, the focus on interoperability has been a little too much, right, because that's early stage, right? When you really want to get to production and scale, it's going to be about conformance. And I think we're going to see a consolidation of test laboratories. I don't think there's going to be enough business, at least not early on, for everybody to have a laboratory and try to make money on it. And then we need the T&E ecosystem to include the equipment manufacturers and the standards to evolve.
Thank you.
The absence of real-world data, I think that's a limiting factor. Everything you just said is spot on. Real-world data that models the actual network, and I think digital twin technology is useful. It gives us a representation of what real network RAN data looks like and acts like. And I think as an ISV who's building a RIC product and building an ecosystem of ISVs around that product, all of that community is really hungry to get real-world data to be able to engineer features that can add value through the use cases that we bring to market. So without that data, interoperability, great, fine.
Yes.
Make sure things all work together, make sure they comply with standards. But beyond that, it's how do you take your applications into a test lab environment and prove that they do what they say they do?
Yes, yes, thank you.
I want to add that the plug fests are also doing a good job in this.
That's helpful.
So every spring and winter we have these, and this has given us a good platform to interoperate and.
Absolutely, and I've participated in many plug fests from different perspectives. And I always thought, this is how you demonstrate to the community that you're a good corporate citizen, that you're, walking the walk, you're not just talking. It's about showing to everyone that you're willing to go. And let's face it, I mean, there's always the fear of failure because things are not plug and play. So it's a lot of work to do integration on the field, and a plug fest is not a commercial implementation, so you're not going to get a PO at the end of it, right? So it's a marketing exercise, but it's important for the whole industry. I think that people realize that it's an effort that is necessary, and that I think a lot of operators actually welcome and take note of who participates and how they participate. So we have those platforms, those rigs, and we have apps that are developed on top of them. I've done a study of most of the vendors in that space, both on the apps and on the rig side, and there appears to be like two schools of thoughts in terms of how those apps can be integrated within the rigs. Some are talking about straight APIs, and certainly the necessity to have APIs that are well-defined and implemented at scale. And others are talking about SDKs, which are also API-related, but require maybe a deeper knowledge of the platform underneath. And in some cases, it's not completely defined what the platform should do. So it's not clear whether you can port an app from one platform provider to another in a straightforward manner. Who wants to take that first?
That's a great question. I think.
Thank you.
We are going to see great progress in the coming years, right? Again, I like analogies. I would say we are still at the early days of doing embedded application development. So two things. The Oran Alliance has done, again, is doing significant work and progress on defining those APIs, right? Speaking from my side, from Juniper, we provide APIs today and SDK aligned with Oran, along with Hello World type of code that simplifies application portability. But it's a bigger problem. When you develop an application, you don't want to worry about how you get the data. So that is taken care of. You know how to issue policy guidance through A1 from the non-real time to the real time. You know how to access, hooks into the DUCU through E2. All that is specified, it's very clear. But an application developer should not have to worry about conflicts. How do I mitigate conflicts, right? That's the job of the rig. So there is a lot of functionality that the rig subsumes and hides from the application. The application should focus on energy efficiency. And there are a gazillion ways of doing energy efficiency, right? Do I do it at the PC setting of the CPU, the server, the data center, the region? How do I do energy efficiency, right? I need to be able to port as many different applications that do part of energy efficiency and not worry about the conflict.
Yes.
So we're still at the early days, and we're going to see libraries coming out, for example, that will address higher order functionality to simplify the development of applications, whether it's R apps or X apps, to focus on the optimization or the functionality that the application brings to the table, as opposed to infrastructure.
As a RIC platform, as Constantine has said, Juniper and VMware both have RIC platforms. If we do our jobs right, if we conform to those standards and we're involved in the definition of those interfaces and we conform to the operation of those interfaces, if we do our jobs right, then we'll be able to achieve a form of portability, which gives operators more choice as to which platforms they use, and they could mix and match, they could have both if they like. It'll boil down to at the end to the individual platform's capabilities and whether or not they can be customized or extended in some way. So adding additional value into that platform, but we shouldn't inhibit the ability to move X apps and R apps between platforms. If we do our jobs correctly, we can enable that.
Yes.
Can I add one? You go first again.
Thank you. So I would like to add the developer community angle here. Being a developer myself for 20 years, let me add, it has to be such that The developers do not have to worry about knowing,
Yeah.
if they know RIC, if they know radio, they can build an app. We have to reach such state, that's when it's a success criteria. We're not there yet, but I'm hoping that ORAN community is working hard to get there.
Well, and just maybe a quick thought, right? I mean, you talked about SDKs versus APIs. I mean, SDKs obviously tend to be implementation specific.
Yes.
Right? I mean, you know, one of the things that will be interesting to see this play out in the ORAN space is just how much do we actually commoditize everything. And if we do, or if we open everything up, right, and expect everything to be homogeneous when it comes to, you know, the expectations for the E2 and what the RUs can do, where are people going to compete? Right, and I think, you know, certainly this is, you know, where the incumbents are competing on the scheduler right now.
Yes.
Right, we open it up, and so now we're having third parties actually compete in the scheduler. So what is the ROI for somebody to enter a market for, you know, what effectively becomes, you know,
commodity.
Commodity, right? I mean, so I think we still have to be careful that there's opportunities to compete in the market.
Yes.
Right, and so this balance between open and proprietary rights needs to be very carefully looked at, so that we don't go too far. Right, and try to do too much, and then we don't have a market anymore.
Yeah, I share this opinion that, I mean, it's not because you can disaggregate that you should disaggregate. I mean, at some point, you have to do your cost analysis benefit and decide whether that's the best way forward. So, sorry.
Yeah, so I was discussing with one of the vendors upstairs yesterday, and they mentioned that they have ported XApps and RApps from one platform to another. And one thing, I guess it's obvious, but we forget about it. Certain RIC platforms support certain programming languages. So maybe the biggest effort was actually translating from programming language A to B. Of course, with the APIs, they are kind of independent of the programming language, but a lot of the platforms provide an SDK that makes it easier to build applications. And related to your last comment about the vendor differentiation in the platforms, I've seen some vendors kind of proposing vendor-specific extensions to the RIC API. Of course, they're very nice because they make it easier for the XApp writers, but then it makes the XApps unportable. So I'm kind of conflicted there. It's on one hand, it's a good thing, and on the other hand, it's not so good thing. So maybe these extensions eventually can be also standardized to essentially higher-level standardized APIs. Thank you.
I was trying to, you know, the audio is weird. I cannot hear you very well. But I think you were advocating for openness, right?
Yes.
Yeah, openness is good. You know, since when openness got us into trouble? So I think that if I understood well, again, you were arguing against opening up the scheduler to the...
No, what I'm saying is I think we need to be eyes wide open about where the balance is between how much we open and where we actually end up commoditizing things so that there's no longer any point in competing. I mean, the margins in this business, right, are pretty thin.
I agree.
So we just need to be careful.
But I agree, but these are two different arguments, right? I think if we argue about technology, where technology evolution is going, you cannot think about margins, right? These are two different things, and I agree. Margins are very important. We all need to have, you know, to survive. But we're talking about technology here, and I think, you know, if we you know, go along with the technology evolution, we'll find ways to create new opportunities, new business opportunities. And I think that's one of the prime arguments that the RIC is going to open up opportunities for the telco, for the communication service providers, to address new revenue-generating opportunities, right? Not just optimization of the radio. So I think we need to separate technology from the business imperatives. And let the two run. You know, we're very creative people. We'll find ways to make money.
I think it's a too good problem to have. Too much openness. We're on the other extreme right now, so we should worry when we get there. I hope we get there.
I think separating technology from business is a philosophical exercise, right?
I agree with you.
Right, I mean, so I think, because again, I mean, you're all up here, right, to make a buck, right? I think I'm the only nonprofit on stage. Yeah. So, you know, I mean, you have a responsibility to figure out how to monetize what you're building, right? And so, you know, driving too far, you know, down one path, right, without the ability to still generate revenue, right, is going to be a problem.
But I agree with you on the importance of working, and making sure that what you do has value, has monetary value in the industry. Where I disagree is on the premise that if you open up too much, you may risk your business, and that's what has created dinosaurs, right, in the past, right? If you don't go along with technology evolution, you fall behind, right? And if the impetus for not going along is because you want to protect your current margins, I think that's a poor argument, with all the due respect, for not, going along and doing the right thing.
Well, Constantine, right? So I am a proponent of ORAN, right? I am all for everything we've been talking about, right? I want to see both the non-real-time and near real-time RICs. I want to see all the interfaces that the ORAN Alliance has standardized actually be commonly available right across a number of different platforms. It's just that, in talking with a number of the manufacturers, over the last couple of days too, right? Some of the manufacturers actually don't know where they sit inside an ORAN architecture, right? Some of them are actually extending things at layer 1 that don't cleanly fit inside an ORAN Alliance architecture, and there's a significant amount of value there. But where does that fit in with the existing reference points? And so that's what I'm talking about. I think there's still places where we need to let industry do its thing and create its secret sauce, right, while still adhering to all the interfaces that we have defined today. So it's just looking for the right balance to allow for that.
I agree. I mean, maybe if we go all the way to support openness on the 7-2 split, for example, right? DU/CU will become commodity. Well, innovation is going to shift on the RU, on the antennas, on the chipsets, on the SoCs. So there is always opportunity, right? And I personally would have no problem with DU/CU becoming commodities. And the value now shifts to the radio intelligent controller, shifts to the RU, right? And the applications.
And it's good to have different perspective, because that's the essence of disruption at the end of the day, right? I mean, you have an established value chain that has boundaries that are well defined, and then disruption occurs, and those boundaries move. Right. And well, yes, to some degree, there's a responsibility to make sure that doesn't destroy value. And that creates value overall, net, right? But yeah, we don't have the crystal ball yet. One thing I want to come back to regarding apps, something you touched upon a little bit. It's about conflict. I mean, it's counterintuitive that you're going to be able to do energy efficiency and spectrum optimization at the same time, right? That you're going to have enhanced quality of experience and that you're going to save on the spectrum at the same time, for instance. I spoke to a lot of vendors that are talking about, switching off channels, enhancing dynamic spectrum sharing, tuning the beamforming in order to enhance spectrum efficiency, and then others that are talking about shutting down sectors and zones. And what I haven't seen though yet is a model for a framework for prioritizing and for optimizing conflict resolution within apps. Is that something that's coming soon? Mathilde,
yes. When we started working on the near real-time RIC, probably like 2019, we realized this as the problem right away. Yeah. And we did some internal discussions on kind of trying to figure out, well, what kind of conflicts could happen and how to resolve them. But then we got busy building the platform. But this is a problem that I've been talking to everybody who would listen to me like years, and I still haven't seen anybody present a convincing
Mari,
solution.
while you were busy, we were building very robust conflict identification and mitigation in the Juniper RIC.
Okay,
I'm proud to say, well, we have a GA release of the RIC, and we have a very sophisticated conflict management and resolution. We continue evolving that, and we provide also an open feedback loop that allows the operator to have a say, right? But it's one of the most important capabilities of the RIC, and it's not going to be part of the standards. Okay, that's where innovation goes, right? The standards cannot tell you how to manage conflicting optimization, attempts.
Well, the architecture has a element component for conflict resolution in the RIC architecture.
Yeah.
Are you able to do the solution in that context?
Yes, absolutely, absolutely. And again, I think we have a very powerful solution there that can be adapted with operator involvement, or you can set it up, you can set priorities, etc.
Is that something that you're going to share with the industry? Something
Absolutely, yeah. We spent a lot of effort over the last 3 years addressing that area. But again, I see that as an opportunity to continue evolving the capabilities. With AI, ML, if you introduce artificial intelligence capabilities, then you have as we have done, you have pretty robust solutions there.
So I want to talk about the beauty of this innovation and how startups are blooming because of RIC and XApps and RApps.
Yeah.
There's a startup, Cohere Technologies, that uses Spectrum and multiplies the use of Spectrum. It can be used at the same time where a Capgemini XApp for energy savings is doing all the magic, but simultaneously, another application can be doing spectral efficiency.
Yes.
So it is possible, and because this is the ecosystem where the RIC can allow multiple apps to run, both these things are possible.
Okay.
Yeah,
and I'm sure there are other innovative solutions out there too that can do it.
Stephen first.
Part of our architecture is really focused on this, and it's top of mind, which is the sharing of data within the RIC, but also the chaining of actions and from multiple, let's say, consumers or providers of this data. So we have to be very careful, as was said once or twice, about the what-if scenarios. Turning off a radio, we're trying to do this, we're trying to do that. Is there a potential conflict? So that's, for us, like Konstantin has said, that's an inherent design principle of what we've built. But I think we have to admit that we're not just going to buy and deploy RICs for one application. It's going to be multi-tenant by design. So this is a very important part, whether it becomes a standard or it's a vendor implementation. The articulation of boundaries and isolations, policy, the rules between sharing data, the rules between chaining actions, the what-if scenario, impact analysis, all of that's critical in the design of the system because the issues are real that you brought up. Disabling a radio could mean a quality of a service or a quality of experience issue for a subscriber, a set of UEs. At the same time, you're trying to do something sophisticated like multiply the spectrum or optimize channel. We need to understand the what-ifs and then act accordingly.
Yeah.
Thank you.
Policy driven.
I'm going to have to cut it short because we are arriving at the end of our session. I want to remind you that this afternoon we have other sessions regarding RIC and RAN intelligence. I'm going to be presenting some of the findings from my studies on the topic at 2:30 in the RIA session. I would like you to join me in thanking our panelists that provided a thought-provoking and entertaining session today, and wish you a good rest of the day. Thank you.
Thank you.
Thank you, everyone.
Thanks, Stephen. Good to have you.
For the next panel, Optimizing Quality of Experience, please welcome Roy Chua, founder and principal, AvidThink.
All right, we'll give a few seconds for the rotation of the audience, so to speak. Excellent. Well, thank you for being here on day 3 of Fyuz, and we're going to talk about a very important topic. You've heard a lot about what the networks can do. You talked about disaggregation. We've heard about the quality of the radio network and where RAN intelligence plays a role. We've heard the word network slicing at least 9,322 times over the last couple of days. But fundamentally, I mean, all that is in service of something really important, and that's the quality of experience, the workloads, the users, us on our devices. And so to shed some light on the topic, to talk about some of the elements of collaboration between the application workloads and the network, we have a panel of experts to talk about quality of experience. And so with that, let's put our hands together to welcome our panelists for today. So if we could have the panelists come out first. All right, very good. It seems like a distance away. I almost need to call him on the cell phone, but anyhow. All right, so we'll do a round of introductions. We'll have the panelists introduce themselves because I'm horrible at pronouncing names. So we'll start with Dahir. Go ahead, introduce yourself, and we'll go this way.
Okay, thank you everyone. I'm Dahir Vergara. I'm the head of OSS for Europe and LATAM regions. We've been working in quality of experience for a big amount of time. Making projects, I don't know, service operation center, customer experience management kind of projects. So thank you for having me.
Thanks, Dahir. Changsun?
Hi, my name is Changsun Choi, and I'm currently working at the Deutsche Telekom headquarters, where I'm responsible for 5G and beyond the topic. That includes right now the 5G end-to-end slicing, QoS topic, and campus data, and then network convergence topic. And I'm so happy to be here and excited to be part of that discussion today.
Thanks, Johnson. Carlos.
Hello, everyone. My name is Carlos Lopez. It's a pleasure to be with you today. I'm the wireless manager at Telefónica Corporation. I'm delighted to participate in this panel to talk about video quality of experience, in particular in mobile networks, where we have a huge challenge with data traffic growing 40% every year, and with 70% of the traffic coming from video apps today, and probably in 2-3 years' time, around 80% of the world traffic is going to be coming from video apps. So, a huge challenge for the overall industry.
Excellent. Larry?
Hi, everyone. It's good to be here. My name is Larry Alder. I work at Meta, and I'm in our infrastructure team, and my team works with the ecosystem, and our job is to work with among the ecosystem carriers on improving the quality of experience for users.
Excellent. And Erica?
Hi, Erica Sievertson. I'm an executive director within strategic development at Comcast. I focus primarily on wireless and connectivity strategy, looking for opportunities 5-10 years and really thinking about the future. One of the things that we've been thinking a lot about is how we interact with applications, APIs, very interested to see how this world evolves.
Excellent. Thank you, Erica, and thank you, panelists, for all being here, and thank you, audience, again. So we're going to talk about one of the key elements, and Carlos brought it up, video, right? I think we all watch a video, we can't help ourselves, and whether it's cat videos or other animals or humans, we tend to watch a lot of that for whatever reason. So given the workloads that we're seeing, especially video and short-form videos being a particular challenge, as well as other performance-sensitive workloads, right? We have all those running on the networks. What can we do to help ensure quality of experience? And I'll start with Erica, but the rest of the panelists, feel free to jump in after her. Go ahead, Erica.
That's a really good question. I mean, it's no secret that data traffic has grown tremendously, and video has been the main propellant for that.
Right.
And then even that form of video has changed, right? In the early days, it was folks just watching YouTube or streaming or downloading things. But with short-term or short-form video, you're starting to see the workloads change a little bit. You see different viral videos. You see ad insertion in a different format. So it changes the demands. It's becoming a lot more latency dependent. And so it's very interesting to understand exactly what that form of video is. But it's dependent partly on the architecture of the network, and it's dependent on a lot of other variables. And so I think it's no secret to anyone in this room or anyone that's online that it's very complex.
Right.
You know, and we're talking about disaggregation, we're talking about all these other things during this conference. There's a lot of orchestration that needs to happen in order for that end user to have QoE. And the thing is, a speed test doesn't actually tell you if that end user is having a really good experience.
Yep.
And so it's maybe not the best form of communication to say, hey, you're getting a great speed, when in fact their video is buffering. And it may be the application, it may be the CDN, it may be something with the device configuration, the encoder, anything else that might come into play for how that video is actually presenting to that end user. And so one of the things that is really important is understanding that end-to-end picture. One of the things that's very interesting about Comcast is we actually kind of have the end-to-end picture in-house. We have NBC, we've got Comcast Cable, we also do wireline and wireless. We've got 30 million broadband customers and then 6 million mobile customers, primarily on an MVNO with an offload network that we've started to build. And so it's a very complex picture and thinking about that QoE. And so it's something that we're relentless about innovating in. But it is fairly complex to make sure that those all work together.
No, I think that's fair. And you point out when the short-form video is a particular challenge in and of itself. It's not the same usual distribution curves, and it's regional, and it spikes up, it goes viral, and it disappears tomorrow, right, potentially. And you're right, speed tests, unfortunately, as much as we would like to believe, that speed tests are no indication of the quality of experience you're going to get with the applications. And the other panelists want to jump in on that? I saw Dahir nodding very, vigorously on speed test.
Yeah, because I remember one challenge that comes to mind is that at some point we start thinking that we have like our fancy little methodology to have everything in place, and then you don't have a feature in some part of the network, let's say in the core, in the I don't know, any I don't want to go to network element names, doesn't have the feature to deliver you that, and then your end-to-end gets broken because you have the round trip time. Maybe it's a good idea to start with, but then you need to know what happens in the middle, and it's not easy to do that. So yeah, I was remembering that.
Yeah, no, for sure. Yes, Larry, go ahead.
Yeah, and I'll just say that, commenting on what Erica said, the applications are different. So we were used to kind of a streaming world where we all remember pulling up the video and there'd be 2 or 3 seconds of kind of blurriness and then it would finally lock into the clear video. That's no longer acceptable. You got to go right to the right quality. So that means the application has to kind of know about what's going on in the network, has to try and predict what's happening. And then some of the networking technologies that were built in weren't designed for that. And so when our side is trying to figure out what to do, and those technologies, if they're not working together, you can get a bad experience.
Yeah, no, speaking of experience, so Larry, now that you brought it up, experience, what quality metrics, right, key quality indicators or KPIs, or what metrics do you believe are important, right, in terms of measuring or proxies for application performance, if you will, and how do you think we're tracking those on today's networks?
Well, before I say that, first of all, I want to say it's great to be at Fyuz, and I want to thank the TIP staff because it's been a really great conference. So it's been a pleasure.
TIP bot member, by the way. So,
But no, that's a good question. So again, motivating this whole topic and why this topic is so important is we just heard video is a huge chunk of the load on the network. And so there's this trade-off between the quality and the load. So the lower the quality, kind of the lower the load. But the one thing everyone's aligned on is we want good quality. No one wants bad quality. But the question is how do you define that quality? What goes into it? How do you measure it? And so it's so important to have a common vocabulary and a common understanding of what some of the elements of quality, and actually how do you combine those elements into one kind of score. So some of the things that we're doing, in looking at some of those aspects, is there's many things that go in, but some of the top things are just visual quality. Visual quality is kind of a key component, but it's certainly not the only component. There's actually multiple aspects of visual quality, but I won't go into that now. Then there is kind of stall performance. So we all hate the buffering, the little thing that goes around. So anytime you're having a stall, that's a hugely negative experience. In some sense, it's more important sometimes in visual quality. And now another big one is the start time. As we just talked about, people are going to want to get into the app, get good quality right away. As they scroll to the next video, they expect it to start right away. So any start time lag are some of the biggest things. So we have these measures, and one of the challenges, again, how do we trade off the quality? How do we even describe the quality versus the capacity? But those are some of the things we look at, and maybe later we'll talk more about how to do some of those things.
Yeah, I mean, that definitely interests me, right? How do you, I mean, I come from the old days where a mean opinion score on a VoIP call is all I know, right?
Yeah.
And the basic algorithms to do that, but video is so much more complex, and the different types of videos, I'm sure, from a user perception, basis, I think that's really more important.
And even the context is important, because if you're watching at home on a big screen is different if you're mobile.
Yes, that's right.
And so visual quality.
That's right. That's right.
Changes, the standard changes as you change the context.
That's right. I want my 8K on my 2-inch screen, like 8K, right? Because I have really good eyes. Anyhow, so any other panelists want to add on that in terms of,
I fully agree on Larry's vision on this. I think it would help to have a standardization of the video quality.
Yes.
We mainly have 3 different flavors of video. We have streaming, we have Reels, we have live videos. So the 3 of them are demanding different things. In some cases, more latency, in some cases, more throughput. So I think it would be nice to have a standardization for everybody else to speak the same language, to correlate more easily the video quality of experience against the network KPIs, because this is a significant aspect as well. And by having a standardization on the way of measuring the 3 different types of video, or maybe more.
Maybe more,
with,
right?
with
there's a new class, it's just called CAD videos, because they're special. Right?
But I agree that sometimes we put a lot of focus on resolution and high quality, and in my opinion, I think it's more important to avoid interruptions, to improve the start time of the video, etc. And sometimes giving too much resolution is against these other things, because you are competing for the resources with other users that are accessing to the network at the same time. So if you are demanding a lot, you are damaging the rest, and we need to have this sensitive. It's not the same to use your private Wi-Fi at home, where you have a small cell for you and your family.
Yeah. Or you think, unless you have like 3 teenage boys who are gaming, then it's a different problem, Carlos, right?
Yeah, yeah.
Right. Yeah.
But in the mobile access is a different thing, and we need to be sensitive to this reality.
Agreed. Erica?
Yeah, one thing I'd add to that, I think being able to standardize how we actually measure quality is pretty important. And then when we actually think about some of the use cases that are starting to emerge, you even think about what Meta's doing with the Oculus and VR, we're still probably early innings on that. And even now you're seeing gaming, it's the voice overlay, the picture overlay, all these other things, and thinking about how those experiences work in concert with each other. It's not just enough to know latency and jitter, it's how do you redimension that experience, and frankly for us it's really important to know when our users or our customers are having a bad experience, because then we can kind of figure out what that issue is, but sometimes we don't know, right? We don't have full visibility into the application layer, the way that traffic hits the network, and so it's a hard problem to solve, but standardizing it, more API-driven capabilities, those sorts of things might solve some of that communication and collaboration.
Agreed, and it's always the network, right, as we know, right? Anything goes wrong, it must be the network. But could be the application, maybe, right? I mean, so it's always interesting. It's like, oh, it's a network. No. Could be the application too, right? So my wife's like, Wi-Fi's down. I'm like, Wi-Fi's not down. The website's down. Right? So it's
Erica brought up a great point.
Yeah. If
the apps are working with the network, the apps have certain information, and the network has certain information. And really, to get the best experience, there needs to be an exchange.
You have to exchange in a way that we all agree to, right? Speaking of exchange and speaking of technologies that we can support the quality of experience, I'm going to go to Chang soon, because he knows a lot about the technology and the technical aspects. He could be what he called an expert, right?
Thanks a lot.
Yeah. So now they've set you up. So anyway, what kind of technologies are available, to establish this kinds of quality experience, right? What are we working on, experimenting with, trying out, right? What's the state of the art today? And Changsun, and then I think Carlos or Tahir, you guys feel free to jump in as well. So go ahead.
Yeah, maybe I can. What happened? Okay, so let me start with some mobile part first, and then maybe I can jump into the wireline part when time allows, and then you can jump into all of the discussion. And then At least let me try to give you a bit of the overview on what is now happening in the standardization, like you also mentioned, and how we can make this application to be aware, maybe thanks to some API technology. So let me jump into that point, at least from the 5G perspective first. Maybe I would say 3 different key technologies that Deutsche Telekom we have actually considered for the commercialization. The first one is, I would say, the 5G slicing. So I have joined that, I think, several meetings, I think, from the Monday, and then I have heard many things about the slicing. So maybe right now, my impression is that slicing is now really ramping up. And I don't know if you're aware, but I think Deutsche Telekom, we have also made several announcements about the trial that we have done so far for the 5G slicing. But here, when I talk about the 5G slicing, this is based on 5G standalone-based slicing. And then I still remember the time that I presented that a 5G slicing plan in front of our senior management. And then first question that I still remember was, hey, Johnson, what is the difference between 5G standalone slicing and quality service that we have used for the voice over LTE service? That was the actual question that I've been asked more than 100 times in the Deutsche Telekom. If we simply jump into some technical detail, I would rather say the fundamental difference between them is, okay, slicing is based on PDU session-based traffic steering. On the other hand, this a quality of this service part, this is the flow-based steering. But right now, you might have the natural question, why people are now talking about the 5G slicing? Of course, there's some strategic reason, okay? Many operators, they really wanted to go to the 5G standalone as early as possible. Therefore, they consider 5G slicing as the way that they can monetize once they invest their lots of the resource for the 5G standalone. This is kind of the strategic reason. But technically, it is also true that 5G standalone-based slicing allow us to change the traffic in very dynamic manner. I think this is also coming from the device side. You probably know that most of a device OS vendor, they are now supporting this URSP capability, which means the UE routing selection policy. And then even from the network side, we can do all of the complicated stuff, like authentication, slicing, provisioning. We can make those things much simpler way than before. So this makes the people to really cautious and to check, okay, what is now available for the slicing. And that makes this kind of the hype as far as I understood. But of course, it does not mean that all of the QoS flow-based steering is not going to happen. I really have to say that, like we already discussed earlier, we have some API which we can actually use to connect between the application and the network capability. Here, I see the lots of the potential. And if you see what is now happening in the Camara API and so on, you probably know that some of the operators, including Deutsche Telekom, we have released the quality on demand API. And this basically allows the third party to be able to control the some network quality. And that could be also connected to the application that maybe Meta or someone else could also propose. So I wouldn't say that QoS flow will die. I would rather say that we have another way of the control, and that is the flow-based control. That would be the second point that I just mentioned. Maybe final third point would be, now many people are also talking about the FOS. This is more or less the IP level, latency management and so on. Of course, there is some point that you have to sacrifice, to be honest. But still, we believe that that would be one of the best way to manage the end-to-end latency in the IP layer. So we are also now trying to check whether that would be really meaningful for the commercialization. And probably we're going to say something on the FOS sooner or later. Maybe better not to go into the wireline part, right? Because I spent so much time. So maybe
you're welcome to do it, or you can hand it over to someone else. You can pick a friend to continue. Like Carlos, I think he's ready.
I think he summarized very well the 5G slicing topic. As he said, we still have other mechanisms to prioritize traffic that we already have in 4G, like QCI. We have 5G QI. We have resource partitioning in the C-band to prioritize some kind of traffic. In a sense, all the advances that are coming in 5G advanced, and in the path to 6G, so are trying to improve latency, spectral efficiency, and everything is helping to have a better quality of experience.
That's excellent. And I would say, given that you're on this topic, let me ask you, so what are the challenges that you're seeing? So you know, you're an established quality of experience. We need to hear Carlos better. Yeah.
Okay.
Audience, yeah. So anyway, now that you have a better mic, you will sound even more authoritative. What are the challenges that you're seeing in terms of tracking the KPIs and that represent potentially impact on QoE in the network, right? What are you seeing from a challenge perspective?
There are many.
Go ahead.
One of the main challenges is the exchange of information between the two ends, no? Because we all have privacy limits. We cannot mix users' data with location, for instance. And this is important to improve the network quality in specific cells where we have congestion problems, for instance. So we need to keep on working together on the way to exchange information inline and inbound and outbound. Outbound is most for the medium term. With automation, we can expose network information to video platforms. Mm-hmm. In my opinion, inline is a longer-term option for standards to mark some IP addresses when you are entering in a congested cell, so that video platforms can help to take steps in advance. But it's not only about network informing video platforms, but also the other way around, because sometimes encrypted traffic is put in a difficult situation to operators to put the right keys UI or 5 key UI to the type of traffic, because we have many options to prioritize by doing this, but with encrypted traffic is more difficult. So we think we need to collaborate, to work together, to explore options, and to test things to understand what is more effective, and in the last then to standardize the way of working for the overall industry, MNOs and CAPs.
Yeah, no, I think that's fair. I think encryption is definitely useful and at the same time, problematic, right, from managing the QoE, because everything looks like port 43, it's quick, TLS, and you're like sitting there and like, well, it all looks the same to me, right? So not great. Yes, Larry, go ahead.
Yeah, I was going to add on to what Carlos said. I think we're going to see, we've talked about like Chimera, what we call out-of-band APIs, out-of-band signaling, but I think we're going to see the times now coming for further in-band signaling.
Yep.
Mm-hmm. And there's a lot of work going on in some of the standards bodies and so forth to find a way to securely transmit information between the application and the carrier to signal things that could be useful. We talked about this quality of experience, and you'd think that the higher the quality experience, the more the engagement. It's not always true. You can have conditions where, and this happens all the time, in some markets, people are on very constrained rate plans. And if you drive a high quality of service, their data plan gets sucked up. So they don't like that. They actually like a lower quality of service that stretches their data plan. But we don't know that.
Yeah.
So we have to take a broad stroke and say, well, in this market, we do a very coarse thing to say, well, let's do this. But if we knew, hey, this person, we should be targeting this quality or that, and the network knows some of that. So there's lots of information that the network knows that they could share probably better in band.
Yeah, no, I think that's critical. So both out-of-band and in-band mechanisms, as you point out, in-band probably makes a lot of sense to the extent that we can standardize that interface, right?
It has to be standardized, of course.
But here the standard also includes a bit of the, let's say, the different standard and the different standardization body. I mean, at least when we talk about some slicing, QoS, and then FOS, we only talk about like a 3GPP and ITF. But the reality is Okay, imagine that our customer is willing to pay or something for the better quality of the service, but then we have to make sure that no matter where our customer is now staying, it could be staying on the top of the Wi-Fi, it could be staying in the roaming situation, we really have to make sure that our customer would get almost the same quality as he would have get in their home network, right? So it is not so easy to make sure that we can provide the better quality of the service in the non-3GPP access, which is Wi-Fi, and also roaming situation. This is exactly where I think 3GPP and the mobile people need to work with a different like a standardization body like IEEE and the GSMA for the roaming situation.
Yeah, that's fair.
And I was going to say, he brings up a really good point. And actually, one of the things that we've been testing more recently is low latency DOCSIS, which, if anyone's familiar with cable, we use DOCSIS as our protocol. And what that requires is a collaboration with the application providers, you know, and it's a standards-based approach. And so it allows for things that are latency sensitive to get a different treatment from the network. And really, this is an approach that we've seen some success with. We've done our trials with Apple and NVIDIA and looking pretty rapidly to commercialize this.
Yeah, and I think that's important. I think it's in everyone's sort of vested interest to get it working. And I think one of the key things that we're pointing out is that it's not just the application and network boundary. In the reality, it's a multi-domain network problem. And the domains may shift depending on where you are, you know, whether you're traveling, you're on the train, you're at home, you're in the office, you're abroad, like here in Madrid for many of us, right? And how do I establish the same quality of experience across multiple domains, which have multiple standards bodies representing them, and then on top of that, you have the application and the network. So your ingress, egress points could be different, right? In many cases, the application could be running on top of a mobile network, or your Wi-Fi network at home, which connects to your fiber or your cable, right, with DOCSIS. How do you provide that kind of comprehensive approach? And I think I don't think it's about saying we got to get it perfect before we start. I think it's about let's pick one domain where we have collaboration and control. Let's start there first, right? And then it seems like mobile's not a bad place to start, right? Because it's a more direct interface in many situations. We have mobile operators here already, and we have network slicing, right? No, okay. And we do have network slicing. It's one of the key applications. But one of the other things that I think, speaking of working towards these standards, right? There's the network API, there's the NNI element, right? That we deal with the network interface elements, right? That's the usual. Uni and NNI never go away, right? It's just takes on new meaning. But on top of all those things, it seems like we need to set some kind of higher level milestones or goals or stakes in the ground that say, TM Forum does these, phase 1, phase 2, level 1, level 2, level 3 type things, right? Level 5 autonomy is when the networks take over the world and control us, but level 6, I think that's level 6, sorry. How do we paint this picture? How do we paint a roadmap? How do we put concrete stakes that people can understand? Like, I think TM Forum does a very good job of doing those things. How do we collectively put those stakes in the ground, regardless of the work that we have to do? How do we define those stakes? They're here. Any thoughts about putting stakes in the ground across so many stakeholders that people can look at and say, I have achieved level 1 QoE, I've achieved level 2 QoE, now I'm level 5, meaning that, when I put on my Oculus or put on your favorite, whatever it is, I have no idea that I'm not in the real world because I've achieved level 5, right?
Yeah.
What are your thoughts?
Yeah, this is a great time to speak about that because I'm remembering many things that we have done associated to quality of experience, the many challenges that we had. I remember actually before answering the specific question, back in the day, several years ago, we trying to understand what actually mattered to the customer was really hard because we could not get application information anywhere, and we could only get the yelling of some customers telling you this is not working, that's
the yelling API,
yes,
customer yelling at
yelling API.
Yeah.
Let's put some Gen AI to that and see if it works. But in reality, what happens is that it is, and you mentioned the MOS for the voice.
Yes.
There are things that can be actually brought from the past, some specific things. Why not having a mouse for video? Okay, and understanding what actually the customer cares about. Because maybe technologically wise, we will care about many things, many efficiencies. We need to do many stuff as a sector. But the customer wants what they want. They want to have the right resolution. Actually, one good finding in the past was that they prefer to have less resolution than spinning resolution. Changing resolution was worse.
Consistency.
Was the worst for them.
Correct. Yes.
That was a key finding. So let's focus on that. Okay. So I'm remembering all those things and thinking that maybe some of those learnings need to be put here. But as you say, nowadays we have much more ways to collaborate. You mentioned Camara, Changsun. Camara project is getting really hot, not only because it makes sense, but also because it's the right time to do it, it's the right time to go forward. Hearing you out, I say, yeah, we will definitely get there and have APIs for the application providers to seamlessly use that. That is awesome. But then I don't see that much of discussion about how to handle all of that to make it happen layer by layer. And actually, one of the discussions we've been having this week was even about data center automation for the air conditioner that is going to support the data center, upon which you are going to support the compute, to put the network function, to put the service and all that stuff. It's getting very, very stacked. I think the top-down approach is the right one. I think we need to put everybody knows we cannot touch the customer data. Everybody knows that. But we can speak between each other from the application down. Okay, that's our specific approach, and try to find the specific things that the customers already care about. Not only video, we've been speaking a lot about video, but also gaming companies. One very important gaming company approached me back in another event, speaking to me about how can I have several mobile user gamers together at some point and not break the connectivity. Okay, maybe try to prioritize. Of course, Camara APIs have the quality of as a service, but maybe it's not even only quality of as a service. It's also how to handle your actual infrastructure depending on what the customer demands seamlessly, not because they told us that they need more throughput or less latency. So. I really think that we need to, maybe or perhaps the right way to do it, or this is an idea, will be to put find some way to share information across all the layers. But first of all, the right information. We already do a tip, we already do groups, but I've been thinking about this, and maybe we need to do some code. Maybe we need some platforms. Maybe we need some software, you know? And I'm remembering that here at TIP, one of my products, the products that I provide is the OSS. The OSS was born here at TIP. The Entity Data OSS was born here with one very important project that we were involved, which was the Symphony project for the OSS. Why not doing the QoE project with code, with platform, with software, to find a way to securely, without getting into any trouble for sharing the data, start getting the same information. I'm not saying that we are going to do a platform where everybody is going to see everything. That's not feasible, or I don't know. Sure. That's another discussion. But maybe to have a safe and secure way to share information among each other. And then we can define how to materialize that in each collaboration scenario.
Yeah, I think that's fair. I think we keep hearing the word collaboration. I think it's key, right? I think the TIP provides the mechanism, right? The MRN project group, which focuses on this, is one such mechanism of collaboration and coordination. And I think the reality is that, I think, as Changsun pointed out, there's all these different parties that have to get involved. I think that's just the reality. At the same time, I think we recognize the problem is highly complex. This is not a simple problem. This is a multi-domain, end-to-end application network with different types of workload problems. But I think if we start collectively by categorizing the workloads, it doesn't have to be all. It doesn't have to be even comprehensive. It has to be the first couple that we know we get complaints about, right? We got gaming, we got video, different kinds of video, 3+X category of videos. Even if we started with 3 that we know about, I think that's a good starting place. And I think if we could communicate that to the other folks in the ecosystem in a concise manner that says, level 1 or phase 1 or phase A means this. Phase B achievement means this. In some non-technical terms, right, that they can understand and say, oh, if I hit 3, I likely can do X, right? And I think if we just started there collectively, I think that would make a lot of sense. I mean, any thoughts in terms of, the last couple of minutes here, or how we do that?
First, I'm glad you mentioned the working group here at TIP. The focus is on a lot of these issues. I'm going to come back to the vocabulary of quality.
Yep.
It sounds so easy. What's the quality of experience? But it's really hard to define that and what elements go in. And I told you before in the green room, I'd mentioned something with AI.
Yes.
So one of the things that we're doing actually at Meta, which I find interesting, is the way we are now estimating the quality of experience is we have users watch stuff, and then we record, well, what was the visual quality, what was the stalls, what size screen were they on? There's about 14 or more parameters that go in, and we create an AI model that then takes those parameters and predicts a number. So quality. So now we have a number that kind of blends all that. And of course, it's a different if you're on a big screen or a small screen, a mobile, fixed, all that stuff. But it allows us to have a common vocabulary. And then we can make the trade-off and say, OK, if we want to go from quality 85 to 86, how much capacity does that cost?
Right.
Maybe we can not drop the quality, tiny drop in the quality with massive savings, or vice versa. And it allows us to have that discussion. So I think the working group here at TIP is a good place for people to kind of come to an industry commonality of how you describe these things. I know video is just one aspect. Then there's other applications. But right now, we're so focused on video because of the load.
Agreed. No, I think in the last couple of minutes here, maybe add your thoughts and do a little wrap-up or call to action or collaboration or whatever. And we have audiences here. They have resources. They have intelligence and expertise. They would really like to contribute and add, right? So, maybe tell them how. But go ahead.
Well, I think that, of course, collaboration is the fundamental topic here. But I have to say that operators are very used to be compared between us with crowdsourcing information, with drive tests, etc. But it's not so often to compare caps between them doing similar things, caps that are doing reels or streaming or live video. And we are starting to collect this data with DPI and quality of experience tools. And we are seeing an uneven use of the network for similar purposes, and we need to understand why. Right. We need to start conversations with the both ends to understand why it's so different, the use of the network, and try to face the problem together, because in the end we all are chasing the same goal. Yeah. So, but we need tools. Operators need tools. We need to monitor. We need to do comparisons. We need to demonstrate what we see, and try to understand why, and work together to flow to the best possible end for this common goal.
No, agreed.
Maybe
yes,
one point from my side. I think this is exactly what Larry you have just mentioned. I think this is like how to use the AI to predict this quality of the experience. I think from the customer perspective, I think this is the way that we have to go together. But this is also exactly where we need a proper collaboration between the network operator and also application provider, like you said. I think there's some information that you can get from the application side, but of course there are some applications that network operator can know or can get from the UE and all of the mobility performance and so on. So I really wanted to stress at that point, I think we need to collaborate together.
We do. And with that, we'd like to wrap it up. We need to collaborate together. The last word you hear from this panel, actually, no, that's mine, but, but regardless, from the panel itself. So thank you, audience, for being with us here. And if you heard, there is a project group here at TIP that you can join, and you can work with these wonderful panelists, and who wouldn't want to? So feel free to join the MRN project group and talk about and work on quality of experience. So next year, when we sit here, we will have a level 1, 2, 3, 4, 5. We will have all the AI models and open source, and we can run those and get the quality of experience, so I can tell whether the cat video will render correctly or not on my network slice, right? Excellent. All right, thank you, panelists. Let's give them a warm round of applause.
Good job.
Thank you. Thanks, Erica.
Please welcome Dean Bubley, founder at Disruptive Analysis, who will be moderating our next panel, Indoor Connectivity.
Hello. Hi, I'm Dean Bubley, and you are sitting in a fairly unusual building. I go to lots of conference centers, hotels, airports, and so on. This one has good Wi-Fi and good indoor cellular. That is actually surprisingly rare, as I'm sure many people in the audience will recognize. We often do not talk enough about the importance of indoor connectivity. About 80% of smartphone use is indoors or in vehicles, and probably about 90 or 95% of overall consumer internet usage is wireless, including Wi-Fi in the home if you add in things like laptops and televisions and connected smart speakers. In the future, as we go to later versions of 5G and Wi-Fi and then eventually 6G, indoors is going to be even more important. Almost all the usage of things like industrial automation, gaming, healthcare, education, robotics, augmented reality, almost all of that happens in a home, in an office, or in an industrial setting. And yet, probably less than 5% of our conversation in the mobile industry is about dealing with indoor wireless issues. So I think this session is going to give a slightly different complexion to what it means to create the networks of the future and guarantee performance, and also bring in potentially new players to the value chain as well. So I'd like to now welcome my panel to the stage, and we've got a good diverse selection of people, and we're really going to drill into some of these. So please come onto stage and take your seats. Thank you all and welcome. Right, now I get to be the lazy moderator here because we don't have much time for this session. It's only a 30-minute one, so I'm going to let the panel introduce themselves. And I'm going to start at the opposite end with Dirk. Dirk, go ahead.
Hi, I'm Dirk Pesch. I'm a professor of computer science at University College Cork, but I'm here in my role as a principal investigator of the Connect Centre, which is Ireland's national research initiative on future networks, where we look at all aspects of future networks, both wireless and optical, from applications down to the physical layer.
Thank you. Andy.
Hi, good morning. My name's Andy Jones, and it really is me without a beard. I'm an advisor at Antevia Networks, an exciting new startup headquartered in the UK with R&D in UK and Canada. Antevia is productizing a new network element in the O-RAN architecture, the front hall multiplexer, which is not a transport layer element. It's an enabler for building shared cell networks out of O-RAN network elements. So that opens up the DAS market and a new novel way to simplify private networks as well for indoor and outdoor coverage, but we're focused here on indoor today.
Thank you. Serge.
Yeah, Shirish Nagaraj. I'm CTO of Corning Wireless. We build small cells and DAS platforms for in-building, so we're in-building specialists, working with US top-tier operators and for private networks as well.
Tiago.
Hello, everyone. Good morning. So I'm Tiago Rodrigues. I'm the CEO of the Wireless Broadband Alliance. It's an organization where we work on making Wi-Fi easier and better for everyone, not only for consumers, but as well for operators and enterprises.
Maria.
Hi, I'm Maria Cuevas, Networks Research Director in BT. So my unit effectively explores all of the evolution of the technologies that we offer to deliver services to our customers. Indoor connectivity is huge for us, both cellular and Wi-Fi, and I'm sure we'll get into more of the discussion. A lot of what we do is not only internally focused, we obviously help develop a lot of the products and services that we sell today, but we also collaborate externally with industry, with the WBA, with Wi-Fi Alliance, with 3GPP, with a lot of the people and partners in this room. room. And very happy to be here. Thank you.
Thank you. And in fact, Maria, I'm going to come straight back to you. I mean, one of the things, we talk about indoor, but indoor means lots of different things to different people. So, BT, obviously, as a major operator, you cover pretty much all locations and types. But do you have like a list of, right, we need to think differently about houses and factories and hospitals? What's at the top of your agenda?
Yeah, I wouldn't say there is a top or a bottom of the agenda. There is the reality is very heterogeneous, and I think that's the thing to obviously evolve to serve the needs of our customers wherever they are. That is the ambition, and adapt the commercial models as well to go with that. You might imagine, it being the largest fixed broadband provider in the UK, we have a lot of households, but even households come in different shapes and types and walls and windows. So that in itself is a challenge, and we've evolved our products to actually help serve the needs of different household types, and we even do indoor, if you like, household type characterization to understand, if you like, the housing developments in the UK, to see how we can evolve, if you like, with the shapes of the houses in the UK. That's just one example.
I mean, that's really relevant, because things like construction practices,
exactly.
It sounds like a million miles from what people here come to talk about, but if you've got metallized windows and insulation in the walls, and it's all very green building, it's also a Faraday cage.
Absolutely.
Tiago, what's obviously Wi-Fi?
Yeah, in Wireless Broadband Alliance, we have been working a lot in making the Wi-Fi experience, especially in public locations, more valuable for everyone, not only for the consumers, but as well for the operators, to be able to utilize as well that Wi-Fi that is available as an infrastructure to complement their capacity and coverage that they need, but at the same time provide tools for the owners of those venues that are private venues at the end of the day, that they understand what are the technologies that they can implement and the different standards that they can implement to make sure that they can provide the best service over a Wi-Fi network and address different use cases, including providing guest services, but as well providing, for example, an offload or a complement to a mobile operator.
And you said that's particularly public venues, so is that places like this?
Like this one, for example.
Right.
We should work in locations like this to provide a very transparent experience for all of us as consumers, that I feel safe, I have a good experience, I come here, I get connected, ideally automatically, and if I want to offload with my mobile carrier, I should be able to do it, or if I want to use any other ID from this venue or from the event, I can do it as well. So I think giving that flexibility is a key element for the future of indoor networks.
We'll come back to automatic connection later on. Shirish, I mean, presumably if you're selling DAS systems, that's a particular type of facility, but I guess in the small cells it's different though.
Yeah, so we sort of cover the whole enterprise space, including public venues and other enterprises. So we sort of segment the market into what's the need for public venues like here or stadiums and such, where the requirements are very different. Obviously, ruggedized DAS plays a big role there. What we also find is, back to your comment on the particular in-building deployment types, we find millimeter wave small cells play a role in stadiums for providing hotspot capacity, and that we've been pretty successful at that as well. And then now you look at enterprise platforms that are more the typical office spaces, real estate, hospitals, manufacturing facilities, and so on. That's where sort of an overall enterprise RAN solution, which is based on Open RAN, is what we are looking at. And it's a blend of DAS and small cell is where we are actually going with that.
Thanks, and I'll come back to the Open RAN in a bit, but it's good to bring in the disaggregation, and I suspect that Andy's going to mention that as well.
Yeah, absolutely. So what Amtevia is bringing is Open RAN-based solutions for exactly those in-building segments that Shirish was speaking to there. And what we're trying to bring is a third sort of option for customers and go-to-market partners, neutral host operators, system integrators, mobile network operators. So if you had this stark decision to make between small cells and a DAS system, we're sitting inside the front hall interface of an O-RAN architecture and doing the copy and combine function that a DAS system was doing in the past, and bringing the ability for O-RAN ecosystems to provide that functionality, and that directly competes then with kind of the premium end of the market in enterprise small cells that have this shared cell concept, which eliminates the interference inside a building and eliminates handovers, so mobility issues inside a building disappear. So we're enabling O-RAN to compete there with Ericsson Radio Dot, for example, or Huawei Lampsight.
I mean, the important thing there, actually, to my mind, is less about the disaggregation per se, but it's about the multi-operator support.
Yes.
Because if you've got a building, in a place like this, you need to support all the operators in the country.
Indeed.
There's no use just supporting one or two of them. Yeah, and obviously some countries do have only two providers. And well, if we listen to Mr. Breton today, maybe we'll have fewer operators in a year's time than we do today across Europe. But for now, there's 3 or 4 in each country. Dirk, from a research point of view, where does indoor sit? Do you focus on private networks in industry or in other settings? What's your focus?
Well, we look at all aspects. I mean, we collaborate a lot with industry in the Connect Center, and we try to understand the requirements of the partners that we work with. So for me, it's really important to understand what's the application, what's the use case of indoor wireless, for example? I mean, is it just to provide data connectivity? Is it to provide voice? Or, in industry settings, for example, so we work with a significant multinational in Ireland who has large manufacturing facilities, and we're trying to understand what are the requirements. They want to bring, say, 5G, for example, into the automation system space. And so at the moment, we have just mobile broadband, really, and so they are quite frustrated at the lack of progress, for example, in particular verticals, in supporting what 5G was promising, for example, in terms of ultra-low latency, massive IoT, for example. They've been using Wi-Fi so far, but there are interference issues and so on. So they are hoping that 5G will solve all of those.
And are they hoping in that scenario that a typical mobile operator will solve the problem inside, presumably, the factory with metal walls, or they go to an integrator, or their robot supplier does it? Who are they looking to solve the problems for them?
Well, currently they're talking to mobile operators because there's no open spectrum for 5G, certainly not in Europe, and so they have no choice but to go with somebody who owns spectrum licenses, for example. And I think if we want to open up the indoor market, we have to look at more flexibility in that regard as well. Because if we lock in the spectrum into licenses, very expensive licenses, I think that has the potential to stifle further indoor deployment.
Just on that spectrum issue, though, it varies from market to market. So in the UK, we do have N77 that's available. In fact, the regulator has made it exclusively available for private network use. Now, I think that needs to be relaxed slightly. I think a neutral host operator should be permitted to use N77 and create a network that serves the public in building and then brings all of the MNOs into that building.
In other words, converging private network and a neutral host in the same spectrum on the same network.
Private network for the venue, for a smart building, but then neutral host for the public as they're moving through that building.
Shirish, I imagine you've probably got some views.
I vehemently agree with that, in the sense that what we are seeing is a convergence of small cell and DAS platforms, essentially, or the philosophies. And really, we need a solution that can, in some cases, be an MNO-led solution with a private network as an add-on, as an application that you provide. But in some cases, it may be a private network that is fundamentally the application, and then you have voice services enabled after that. So you cannot prescribe what's the right solution going to be and just build one pointed solution. You have to have a solution that's flexible enough that can operate in this way or that manner. And that's I think, where we are going. And the roles are changing as well between the operators and the neutral host operators, as well as the VARs and SIs as well.
Tiago, you must be laughing at this because
Wi-Fi. I just want to bring one other angle. As you mentioned before, so for me, Wi-Fi is the incumbent wireless technology for indoor. everywhere. So you mentioned 80% of the IP traffic goes through Wi-Fi. I saw countries that even go higher than that. So Wi-Fi is already there. So I think there is a huge opportunity to be explored of, together with private cellular as well, when needed and when it makes sense, to explore as well, how can I utilize that infrastructure that is already in place, and I can use the latest techniques, including Wi-Fi 6, 6E, Wi-Fi 7 coming, that will make much more powerful and higher capacity Wi-Fi that can deliver a lot of use cases. And that will optimize as well investments and oblige that operators and venue owners somehow to start, and different players on that ecosystem, to have a different approach of what they have been doing until now. They need to do more partnerships. They need to be able to understand what are the requirements of each of these players, and explore that opportunity as well, because Wi-Fi is already there. And by the way, all of us on this room, we have Wi-Fi only devices that we use every day. So Wi-Fi, we need it.
I think if this was to become the Wi-Fi versus cellular panel, you'd be entitled to get up and leave. It's honestly about complementarity, not competition.
Yes.
I was going to comment on that, if I might.
Go for it, Maria.
Because I agree. I think using all these tools to serve the needs of our customers has to be the end game. I really don't think this should be a fight, but there is an awful lot of this is my technology and my business, and I will protect it. And I think we need to break those barriers as an industry. They are just technologies. I don't think the customer cares what technology we use to deliver the service to them, and what they're looking for is solutions.
Yeah. And I think the question really is, like, all of these technologies are complementary, but you have to really look at what are they bringing to as value to the end customer. So for example, mobility and security, I mean, this may be a controversial thing, but maybe cellular has an edge, emergency services and so on. And in other cases, I agree, Wi-Fi is there. That's the default. We are not actually arguing Wi-Fi versus cellular. Wi-Fi is there, but how can cellular augment and provide the needed public services is one way to look at it.
One use case that we've seen is in brownfield deployments in buildings where structured cabling is not necessarily in place. 5G as the structured cabling, augmented by Wi-Fi as the access, is a very, very credible solution bringing both technologies.
I see that quite a bit, is sort of using 5G or perhaps millimeter wave as a backhaul to an access point, and that's happening in sort of outdoor as well as indoor settings. One thing I would quite like to touch on, though, is scale. Yeah, this is an unusual building because it's one of the biggest conference centers of its type in Spain. So it's a headline venue. We talked about stadiums, but there's tens of thousands of hotels. There's hundreds of millions of square meters of office space, shops, banks, you name it. And there, realistically, how many buildings can have dedicated indoor systems installed? Do we need to be training 10,000s of engineers and installers to do that? Or do we have a sort of a maximum number that we can realistically expect in any country? It's 100 a year, 1,000 a year. Maria, from your point of view, how many projects a year does BT get involved?
It's a really good question. Rather than starting from the engineer end, I might start from the, if you like, how the solutions should evolve. And I think this conference has been all about openness and things like virtualization, cloudification. And I really think the ultimate benefit of all these things is actually scale. So the way we are able to independently scale, perhaps control plane, user plane, but build it in a different place in the network, depending on, again, what the venue may need. Some venues might need their own edge, whatever that means. Data on-premise versus on the cloud. So a lot of that flexibility and the ability to consume and build and flex those services on demand is absolutely one of the benefits of all the things that we talk about here. It's not diversification for the sake of it, it's for the purpose of what you just said. I think as you get closer to the end customer, of course the scale needs to happen in the last mile, if you like, or the venue itself, and that's not going to go away, but there are loads of businesses who specialize on that. And we go to people's homes to fix their broadband, so why not? So and they are almost different. And we have an OpenReach fleet installing fiber all across the UK. So I think we need to look at these as a proximity play for the whole, installed radio planning, everything, versus a scale play on the control side of things.
Thanks. Dirk.
Yeah, I think for me there are two main issues in terms of scale. One is that the typical IT departments of organizations, they're not radio engineers. They don't know how to install reliable wireless systems. I mean, I see that, and hopefully nobody from my own university will be here, but I see that in our buildings, where I would argue that the Wi-Fi is suboptimal, and so we need more expertise there if we can get that. But I think what we actually need is, because we unlikely will get that scale of expertise, I think what we will need is we'll need to figure out how can we create indoor wireless networks that will manage themselves, and if they underperform, actually let somebody know that they're underperform. And I don't think we have that at the moment. I mean, even the manufacturers and operators are all talking about, self-driving networks and so on, because they're already seeing the scale for outdoor, never mind indoor. Yeah. So I think there is a huge gap there that we need to fill, and there's plenty of scope for research there.
Whether it's the engineers, the lawyers, the bottleneck, I don't know. Shirish, from your point of view, or your VP of sales point of view, what number would make him or her happy? If it's selling 1,000 systems a year, or 5,000 systems a year, or 100, how many zeros?
So we are very far from where we want to be as an industry. Indoor is really not looked at as a priority right now, and that needs to change. And I think neutral hosting is the way to go, and sort of that becomes a public good. I think we have to get to at least thousands of deployments a year to really start to scale. And there's no question, actually, going at sort of linking back to your previous question, the one thing that's really holding back is the fact that these systems are too complex to deploy. And any way that you can actually try to automate that, make deployment automation, this is really brass tacks on the ground, who's doing what. If you can make that remote, make it automated, that's really key. And otherwise, the amount of time we spend correcting mistakes on the field, it's just not right. So,
Tiago, I mean, presumably, I don't know what the exact numbers are. I'm guessing there's like 200,000, seriously good certified Wi-Fi engineers, and probably 5 million who can put a few access points around a building. Yeah, there's got to be some large numbers of people who can install Wi-Fi in an enterprise site. There's probably 2-3 zeros different to cellular. Do you see that gap narrowing, or are they going to cross-train, or what's going to happen there?
Yeah, well, we cannot compare, to be honest, in terms of capacity to install Wi-Fi and Wi-Fi network or a private cell network. They are at different stages of evolution and the growth of the market. What I can say is, in WBI, we are doing a huge work in terms of guarantee that the consumer market can take benefit of Wi-Fi, but as well from the private cellular networks. Because we believe that in venues like this one, it makes sense to have both technologies running in parallel, addressing different use cases, different type of devices, and different services. And one thing that we do is on the open roaming. So open roaming is a standard to have automatic connection to the Wi-Fi with an automatic discovery of the network and a secure attachment to the network. That we can use the same ID that we use on Wi-Fi can be recognized by a private cellular network. So if the device has both radios, why not using the same ID? So I don't need to replicate multiple IDs on my devices by using different technologies. So that already happened with the public 5G network or public 4G network using the SIM card credentials to the Wi-Fi. Why not as well expand to the private cellular? And I think that will break some obstacles for all of us as consumers to start benefiting on a daily basis of private cellular.
Yeah, absolutely. I'd like to sort of put a more optimistic view on closing the gap. I mean, you have a long head start in simplifying Wi-Fi for unskilled operators to install and manage. But there are two dimensions to simplifying the cellular private networks or neutral host networks to close that gap. One being in the automation and the SMO and the management plane, if you like, and the other being inherently in the architecture itself. So I believe that our view at Antevia Networks is that a shared cell approach eliminates the planning required for a small cell network. So it's intrinsically simpler. And then on top of that, we leverage, and I think this is absolutely, I agree with Tiago, all of the innovations in, take for example, just a Juniper Mist solution does natural language programming. You ask that system, you know, how's my Wi-Fi doing today? And you get an English response. That's where we need to get to. And if we can leverage, you know, systems already, you know, technologies already developed for the Wi-Fi space, for the private cellular, then that's how we close the gap.
And one thing maybe just to add to that is we should not forget the commonalities that can be leveraged in the transport space, whether it's powering or fiber and cabling and so on. We tend to ignore that oftentimes, but that's actually very critical, that you can get that transport layer done once, and then you can hook whatever devices at the end of it, and that's really critical from getting that scale.
I mean, the power is always important. It amazes me how many times, even I forget that it may well be wireless, but you still need to plug it in somewhere, unless it's got a battery.
Power over Ethernet.
Yeah, power, exactly. All right, we've got 3 minutes left. I think one thing, talking before, we all seem to agree on is that there needs to be more focus on indoor, not just in the technology industry or enterprise, but also by governments and regulators. So, you know, keeping it to time, what would any of you like to see? Is it about spectrum? Is it about subsidy, R&D? Is it competition issues? Or even just talking about it more? Maria?
I think we're kind of lucky in the UK in the sense that we have a government who understands that telecoms is an important issue for the country, and actually they are making huge progress towards funding collaborative projects to make progress in different areas. I think from this specific angle, there could be a little bit more emphasis on that. I think there is a lot of emphasis in areas like Open RAN, for instance, at the moment, or the future of 6G, but perhaps finding more projects in this space would be a useful thing to see.
So, I mean, certainly the wireless infrastructure strategy document that was published well, for a start, it mentions the word indoor, which I think is quite an advance compared to most policy documents I see.
Absolutely.
I'm going to get to the other end. Dirk, what would you like to see from?
Yeah, I think it would be good to have spectrum as well. You know, kind of if we want to have more coverage indoors, we likely need more spectrum. Question is, what spectrum? You know, could it be shared with Wi-Fi? Could it be 6G? Around 6 gigahertz, for example. You know, is it millimeter wave? What might it be? You know, and I think we need to look at all of that, and the regulators need to work actively with all the players to explore that.
Andy, what do you want to see from government?
Well, certainly regulators to be regulating around where the future direction is going rather than around historical architectures. Definitely shared spectrum solutions and really agile, dynamic sharing of spectrum. And yeah, MNOs to relax a little bit about a neutral host approach that either leverages a MORAN or a MOCN or other kinds of architectures, and finding ways to square the circle where they can assure the quality of the experience for their users, but it's not actually them delivering the infrastructure.
Yeah, I think that's always going to be an issue where there's a third party in the middle, particularly for things like network slicing on someone else's network.
Yeah.
Shirish?
Yeah, no, I think just recognizing that indoors is underserved today, and it is a public good. And so from that standpoint, we need to have more maybe incentive schemes maybe to actually enable neutral host deployments to actually get kick-started. And the other thing is around specifications. Try to get to a minimum viable specification, not overcomplicate the indoor solution, because that can definitely kill it. So you need to keep it simple, make it meaningful, and that's something that governments and regulators can help with.
Thank you. And finally, Tiago.
In 2 seconds, I think it's important to raise to the awareness to the regulators of the future of these venues, like this place, like this Congress Center, is a multi-radio environment. So just discuss with them that this needs to happen because of the demand of the traffic that we have that discussion with them.
Thank you. And my take, if I had to give a soundbite to governments, it's like start going beyond fiber to the premise and start talking about gigabit to every room, which it doesn't have to be wireless, but it probably will be. With that, I'd like you to thank the panel for a fantastic discussion. And
Thank you.
Look forward to the rest of the event. And thank you to Fyuz for inviting us. Thank you.
Go this way.
Now, chairing the fireside chat, Programmable Networks, please welcome Lucia de Miguel Albertos from Vodafone.
Hello. You are the people who are surviving all the sessions, or at least the people who wanted to hear about the programmable networks. So welcome to the Network Programmable Fireside Chat. It's a pleasure to stay here. When you hear programmable networks, we have the goal, it's clear, to reduce the deployment of services for the customers. But with some examples, we have more clear. In Mobile World Congress, we launched the 5G in a box. The 5G in a box is combining the Raspberry Pi 4 with a small 5G software-defined radio to give the customers to a mobile private network. At the end, is to democratize a product for everyone. Another example would be the run automation. The run automation, you are trying to get 5G connectivity in one click. So the power of the software. But let me, I think, to drive you in the world of the programmability networks. And welcome to my colleague, Ray Dolan, Chairman and CEO of the Cohere Technologies, Udayan Morheji, Senior Fellow of Intel. So welcome. Welcome. Open RAN, at the end, is a software-defined radio architecture where we can see the potential of the programmability. We are working on open all the interfaces and to have a real software compatibility or software, at the end, portability across any hardware. This is, I think, the chimera or what is one we wanted to reach. However, there are comments, discussions, conflicted, and we saw in the first panel today about the degradation of the hardware and software and how we are managing the L1 acceleration. So my first question is for Udayan.
Okay.
How Intel answers the comments of the lack of competition within the Open RAN compute silicon ecosystems, where Intel dominates with a strong maturity and commitment from key software vendors?
Good afternoon again. Actually, we at Intel has been passionate about software-defined networking and virtualizing the network functions for a long time. 10+ years we have done the research on that, including creating a software framework called FlexRAN, that we actually gave it to all our partners, 135+, free of charge. And by the way, and that works in x86. x86 architecture is essentially Intel. You also have another competitor there. But you have a lot of other silicon vendors coming in the Open RAN side of it. In the morning, you heard about Marvell. You have Qualcomm, you have NVIDIA's, but they have not probably invested as much time and effort into the Open RAN elements that we did. So we had the initial implementation, but we welcome competition.
Mm-hmm. Thank you. Now, Ray, it's your turn. We know why choose some operators to test your multi-G initiative, but why Cohere choose Intel's fresh RAN architecture?
Well, thanks, Lucia. So we picked Intel 5 years ago as a partner. I'm thrilled that we did. There are probably several key reasons. One was the strength and depth of their wireless team. They really do know wireless. I've been in the industry, fortunate to be in the industry since 1986, so it takes a while to really understand all of the complexities, especially when you're trying to take this network apart and put it back together again. And they've got the team, and it's only strengthened over the last 5 years of our partnership, where the team in place has gotten even more experience, and they've continued to augment themselves at all levels. So that's one. Their commitment to being truly open and programmable all the way down to L1 was essential for us, and that was a really interesting part of the debate that Paco led that got quite animated, and I think Christina did a great job describing why innovation only happens in a fully open and programmable network like that, and we're finding that. We'll talk about it later, Lucia, when we talk about multi-G, which would never have been possible to do other than in partnership with Intel. And then finally, the operators trust Intel. They've got the global scale and commitment, and they've built, over the last decade, a level of trust that really opens doors, and this allowed us to layer on top of that in a very confident way. So for all those reasons, that's why we picked Intel.
Yeah, great. Until we move to the multi-G initiative, because I have a lot of questions about it, is Udayan, what is your thoughts when you hear programmable processors? Are the possible evolution that all of us need?
Yeah, software-defined networking, this term has been there for a long time. We started actually doing it in packet code. Mm-hmm. So packet code is now majority of this fully virtualized software-defined. But radio access network, especially the layer 1, was the toughest one, as Ray mentioned briefly. The virtualizing that, fully making software programmable, because there are a lot of latency and sensitive timing elements there. But that is what took a long time. And now that we have implemented that, and by the way, this has been deployed now. First started the LTE back in 2018-19 with Rakuten. It's all public data. And then Verizon now implementing at scale on the massive MIMO 5G and other companies as well. So we have gone to that level. So it's already fully programmable, elements of it. And then we are enhancing the silicon. This is the same server silicon that we use in our data centers. So data centers, a lot of competition. Same thing will happen here as well. But you get a lot of benefit on the power optimization, you increasing utilization, things like what data center people have been doing for a long, long time. Ask AWS, ask Googles of the world. They have been doing this for a long time. We want to bring that and economy of scale into this. So it's already happening. It's a fully software programmable at this point. Now, adding to that, in a multi-G framework, your new waveform comes, you have a software platform already. You can actually implement it in there. So that's the whole idea, that tomorrow, whether it's 6G or some other G, new software elements comes, channel estimation changes, MIMO changes, you can implement that in the same software programmable way. And silicon is ready for that.
Thank you. And now we move again to Ray, but I think as with the sample, we learn more what is the programmable network. We wanted to learn more about multi-G. In April, we launched a press release together with several, I think, collaborators to push, at the end, the open interfaces to improve the performance and reconfigure it. We are now in the field phase to test it in real. And Ray, tell us more how to get these impressive benefits of performance and capacity for all the radio assisting networks.
So first, let me explain what we mean when we talk about multi-G. So we're talking about full coexistence, and in this case, we're starting with 4G and 5G because A, they exist, they're fully standardized, the operators are deploying them, and we're trying to fulfill the mission that initially was called DSS, or Dynamic Spectrum Sharing. Of course, we all know that that ended up not playing out exactly as planned because there were two monolithic technologies that were tried to be applied together, and they competed against each other. Now, in a fully programmable network, all that competition up and down the stack could have been resolved fully with software-based changes to the signaling control plane as well as to layer 1. But in isolated packages, it ends up backing off the performance of both, right? It's just that simple. So in a multi-G environment where we're working with Intel, we're actually able to make all of those changes and fully align layer 1 up through the full stack with a common scheduler across multiple PHY layers and show the full coexistence of two different physical layers. Now, once you show that, you show the question is, well, if you can make 4G and 5G work together, can you make other things work together? And the answer, of course, is yes, right? And that's what we'll usher in when it's time. We're not going to start evangelizing 6G in this forum, but when it's time for a new waveform that might be needed either for a specific vertical like defense, and we talked about that at Mobile World Congress, or any other vertical that wants optimized stack all the way down to programmable layer 1, it will just attach to a FlexRAN architecture as simply as we've been able to attach. Now, the performance comes from the Universal Spectrum Multiplier, the USM. It's universal because it operates with both 4G and 5G, and we've already proven those individually. Now we're going to prove them in the same package with you, all right? So later this year, early next year, in Ciudad Real, we'll demonstrate that we can put these technologies together and allow them to coexist, and then the industry will see a path to an open silicon architecture, fully programmable down to layer 1, that scales, and I'm sure you'll continue to improve the scalability and power performance and compute performance, and together we'll drive spectral efficiency, and then operators will have a common extracted control plane that sits above the various physical layers. And that control plane can attach to a service creation layer and allow operators to finally fulfill their drive into the enterprise and a drive into other industry verticals. So it's a very exciting opportunity, and we appreciate the opportunity to do that with Vodafone.
Yeah, it's very exciting. I don't know if you can share with us with which operators, or what are the field trials that you are doing, because sure, one of them is Vodafone, but I know that there are other operators in other parts of the world.
So the first thing we did in 2020, right before the world shut down with COVID, was we did a very small trial with Deutsche Telekom. It was a single site. It was designed to be relatively primitive as far as like just demonstrating a shared pipe versus a replicated pipe in space. And we did that in partnership with you and VMware, and as a result, we ended up having very strong relationships with both of those companies, and both of those companies are investors now in our cap table and strong partners. The next thing we did was a lab trial with Vodafone and proved that we moved from 4G to 5G, and that's where we proved that this was in fact universal. Since then, we've been in the field with Telstra. That's well known. There are limitations to what I can talk about there, but we're very, very pleased that we've scaled into the field. We're running on Dell servers, the Capgemini stack. It's all Intel FlexRAN based. And we're working through off-the-shelf radios, off-the-shelf antennas, and off-the-shelf handsets. So nothing we do in our spatial domain at the Universal Spectrum Multiplier changes anything in either 4G or 5G as a spec, nor is anything required out of the handsets for it to be different. Now, additional performance benefits could be gained if, in fact, 3GPP changes were made above and beyond what exists today, but we're not pushing on that. And we've achieved basically, when we can spatially multiplex, we achieve 2x. So the real debate is, how often are you able to spatially multiplex, right? And there's a certain separation, angular separation that's required. In a congested site, that happens almost all the time. And then there's mobility constraints that may or may not happen over time. So we're seeing about a 2x benefit in spectral efficiency. I say about because I'm not going to argue over marginal differences as we back off that claim. Most of the operators that I talked to said you had me at 1.2, you had me at 1.3, you have me at 1.5, because remember, there's $1 trillion of spectrum in the industry today. If you can make a 30% improvement on that, it's a pretty big number. So we've been able to raise a significant amount of capital along the way. The company is funded until at least the end of 25, if not more so. So we're a healthy, vibrant company. We're growing, and we're looking forward to the project with you in Ciudad Real.
Yeah, very attractive number. Yeah, I think we can change a bit. I think to the Open RAN interfaces. Udayan, how this initiative do you think is enabling faster the RAN adoption and unlock the new innovation?
Yeah, just as a background, I mean, as you said, we said that Intel has been in this for more than a decade. We also the founding members of the ORAN alliances. Before even ORAN started, there was something, and people may know, it's called XRAN. So we did that with Stanford and many other some other companies. We talked about low-level split interfaces there itself. So once ORAN came, XRAN was absorbed into the ORAN, and they took over that programmable interface, the low-level ones. So we created multiple groups there. So one is obviously this front hall interface, well-defined now. This is 7.2, and there are some enhancements as well recently that has been getting implemented. 7.2 splits are there in many other implementation right now. But the other key elements of this, and as you go up in the stack, the E2SM, in the scheduler side of it, this is where a lot of the next generation of innovations with RIC will come into play. The whole idea now, Lucia, is that software programmable network is given. In Intel, we have a belief that anything that can run in software will run in software. You're not going to have a custom silicon or ASIC just for that. It's not scalable. But how we expose the data, power management data, IQ data, channel data, a software programmable platform will expose all kinds of data. What do you do with the data? I mean, just data without any kind of inferencing is meaningless. So a lot of those innovations on top of this is going to happen in RIC. That's why that E2SM model, this is where most of the focus is. It's getting matured. There are still going to be enhancements in this. And a lot of these new applications are being developed. One of the key ones is the spectrum multiple, the scheduler that Ray talked about, but many other elements from companies like Junipers, VMwares, and many startup companies, IRA. I mean, I saw Anand here. I mean, a lot of those things are being built on top of those. And this is where the enhancement going, and ORAN Alliance is fully behind this.
I think you almost anticipate my next question to Rai, because it was, is it possible to do in traditional networks? And the other, how easy or difficult was to move this initiative to an XApp?
So let me handle the second question first, if I could. And so we've actually moved it to an XApp in a VMware RIC. And I should also give a shout out to Juniper, who's also an investor in our company. We're in the process of working with them as well, because they've got a very well-trusted and operator-friendly RIC platform. They're very committed to the category. So we can get this moved to an XApp, but we're also happy to work locally. Not every operator is ready to go with a RIC. Not every country has the development of backhaul fronthaul capabilities that exist in major cities. So we'll have both a local implementation as well as a RIC-based XApp implementation. And that extraction, I wouldn't say it was trivial, but it was relatively straightforward, because we are in fact transparent to the physical layer. So we're already operating above that. So yes. So we're naturally layered. Our USM naturally operates transparently to both 4G, 5G, and in fact, even OTFS. Some people have said, will this work, will your USM work with, or your multi-G platform, would it host OTFS? My answer is, they were born in the same womb.
Exactly.
They had to be extracted in order for us to insert our USM into 4G and 5G. So we actually create a very natural path to migrate to a next-gen technology to the extent the industry's ready. Now, let me see, your first question was not the XApp, but was...
Yeah, I think the first question they
interfaces?
have at the end, it can be not good, because all the traditional networks, they will be Open RAN in the future, because Ericsson, Nokia, they announced their products. But is it possible your multi-G initiative in a traditional network, or what will be the challenge to introduce it?
So thanks for that question, Lucia. And I need to be thoughtful here, because we've actually begun those discussions with one of the largest players. It is possible. It's not trivial, but if in fact the same information gets exchanged in the architecture that we've built today with Dell servers and Intel FlexRAN and Capgemini, and all of those exchanges are made, which we're planning for across a standard E2SM interface. So if those IQ samples in the uplink are shared, in fact, and they're there in that network, if they're shared, and if we're able to do our math and insert our software and logic in, and then we have two choices: become the scheduler, which is a little bit audacious to consider when those companies are not going to let that happen, or we can simply inform their scheduler as to what the spatial plane looks like, and absolutely the same performance will be delivered. Now, why might that happen? Well, we are at least this way. We are focused right now on FDD, because the biggest congestion that exists in the world are on low-band FDD networks. To my knowledge, there's not anyone out there that is bringing a product to market that can deliver spectral efficiency benefits in the spatial plane in paired spectrum. Everyone's working on massive MIMO, 64TR. Everything we've done so far in Telstra, everything we did with you in the lab, and what we will do with you in the field, and we're also working with Bell Canada, who's also an investor. We'll be doing that in Toronto. All of that will be in 4TR antenna configurations, paired spectrum, and at least in the Bell Canada case, it will probably bring in one of those vendors at the end of the trial. That's the discussion that's being had right now. So I'm not going to get any further ahead as to naming names, and that may not happen. These are conflicts and issues that people are going to have to address, but the opportunity to help global operators significantly improve spectral efficiency in the low band in paired spectrum right now, while they work on getting additional spectrum, is so critical that I think at least somebody is going to engage with us. And when they do, we will make it, I believe we'll make a huge impact on the industry. And there's at least one operator in North America that's supportive of that idea, actually two, one in the US and one in another place in North America. And there's at least several around the world that are pushing that vendor to do it.
It sounds very well and coherent at the end. Moving a bit to open more, I think, our ecosystem, and we have application that they can demonstrate the intelligence of the network that can be moved to the rig or the RAN intelligent controller. How do you see the creation of a wide multi-vendor ecosystem? Do you think there are a lot of actors, or there are a reduced number of people who are doing things? Both of you can answer, or we can complement it.
I think it just got started, right? I mean, there'll be more companies joining. I mean, I'll give an example. I mean, in last Mobile World Congress, Microsoft demonstrated how to extract data from layer 1 data out of a FlexRAN systems, and they have created a framework, and it's public, Janus API. If you Google Janus, you'll see their white paper on these things. They're creating a lot of those intelligent functions on top of it, fault management, many other elements. So we started it because there's mind meld here in companies like Juniper and others, and then, you know, Vodafone. but we will have more and more companies joining us, and it's open to all. Ray?
Yeah, we see it being a fairly vibrant ecosystem, although it's not for the faint of heart. As you know, there's some companies that went for the entire CU/DU architecture, and I don't think I'm naming names out of school, but companies like Mavenir, companies like Rakuten Symphony, these are huge challenges they took on. I have tremendous respect for what they're aiming for. And they're making tremendous progress, notwithstanding some of the press that people put out there. And ultimately, I think their odds of getting across the chasm and scaling to become very successful companies, even with the challenges that are going on in Japan right now, are pretty good. It's just, but this isn't for the faint of heart. And then there are smaller players, for example, not smaller but RIC, which is not necessarily the entire piece, smaller in mission, but very large players are making great progress there. Incumbents and new players into the category. And the RIC is going to be a really interesting place because it may take a few years, but it's going to be where the control plane sits if we're successful. And if you put that control plane attached to a service creation layer, that's going to be 95% of how operators differentiate themselves. The rest is going to be commoditized if it's possible. And when I say commoditized, I don't mean worthless. I just mean it's going to be done in a common, open, software-based architecture across general purpose silicon, and that may be high margin, but it's going to be common. And it's going to be less differentiated than the pieces that are evolved into the RIC. And that RIC is going to become, I believe, a very vibrant app store, if you will. It's almost like the app store in a traditional smartphone sense, but it's going to become the app store of how operators run applications on their network.
Yeah, I think we share the Apple, I think we call it the application store.
Okay.
I think we're a bit run of time. I think we are close to the finish. We are going to the last questions that I think you commented, and we can do a bit deep dive in this part. The challenge, the main challenge to the programmable networks. What you are seeing? Security, openness? What are your thoughts when you say, what are the main challenges, not only for your, I think, application, I think in your domain, if you are thinking in the networks, in the openness of the networks, to have a software really portable, what are the main challenges?
I can start. If you look into back in 3G and 2Gs, an early part of 4Gs, how the network was built? It was all appliances, vertical appliances, custom. There are DSP silicon, but there are mostly custom ASIC that has been built, and operators are actually, it's a one supplier, top to bottom. Opening up that industry with multiple more ecosystem players takes time, which is already happening. There are no technical challenges for now. Even when we look into 5G, is given. 5G getting deployed massive MIMO in a tier of 44R. I mean, in areas like not just US, in India and Europe, in UK, that you are doing. Now it's all about TCO, total cost of ownership. So how do we keep reducing the TCO? How do you aggressively do power management? One of the, if I may, I'll tell you that back in 2011, there was a seminal paper from China Mobile on Cloud RAN, where they talked about why are my base stations not being utilized. So I think that has already been proven now, but is now how do you aggressively do the power management, bring the TCO down, and take more and more deployments, case studies to show the world, because it takes years to actually get to that momentum. It's happening.
I'm not sure if you wanted to add something more, or we can close here, only to thank you for this, I think, amazing discussion with you. And thank you to everybody to support. I imagine that the people are beginning to be starved, and it's a session a bit more challenge for the time. And thank you for the online attending too. So thank you very much.
Thank you.
Thank you.
Please welcome Sean Kinney, Editor-in-Chief from RCR Wireless. who will be chairing the last fireside chat, New Fields for Innovation, Takeaways from Fyuz 23.
Seems to be just the true believers here at the end of the day, but we appreciate you sticking around with us. You'll note that I was the only one that received an introduction because I'm the only one of the three of us that need ones. You all know Canis and Laurent, so please welcome them to the stage. We've got a big topic today, so we're just going to go straight into it. New fields of innovation. It's a bit ambiguous, so let's ground it a little bit. For your organizations, when you think about innovation, when you think both about innovation short-term and tactically, long-term and expansively, and the balance between them, take us through the internal logic. Take us through what guides how you approach this. Canis, can we start with you?
Yeah, sure. And thanks for inviting us for this conversation, Sean. Yeah, so innovation to us is not a one-off thing. Innovation is a continuum that starts with a concept creation, and it goes all the way to the adoption of technology in the operations and deployment, but then also adoption of technology with the human beings. So you see, technology influences the human behaviors, and the cycle is iterative. So it's the known and unknown influences of technology into human behavior that basically is advancing the further evolution of technology. So that's what we believe in. And the other essential element that we practice is co-creation and co-innovation. So we don't do it in isolation, and that's why we are here. We love to do innovation with our partners, sometimes also with our competitors, and we continue to innovate as we grow.
Laurent, what would you add to that?
So thank you, first of all, to have me here. I would say that for us, we look at innovation with different time horizons, and it's not innovation which is purely tech for tech, but it's really a tech for humans, and also tech for the planet. I mean, we try to make sure that what we will bring to our customers are also sustainable in the future, and that we play a very strong and really sustainable role in the society. We try to listen also to all the signals that we get from the society. For instance, when we try to prepare 6G, I mean, understanding really the needs and not try to push just technology for technology. We have also a few areas where we try really to create something very new, like for instance on quantum key distribution and how we can secure communication. And it's a little bit for the future, but we see some application also that could come in the near future. We try also to look at solutions that could help also to have an IoT space which could be which could live also even with passive object with no batteries, and we believe that at some point it will become extremely important. And then if we look at short-term innovation, we try to look at it both from a top-line standpoint, and clearly what we're doing now with telco API, camera, and so on is how we can monetize the network. It's in this space. But we try also to look at innovation from an efficiency standpoint, how we can automate much more operations, how we can save both CapEx and OpEx and so on.
So based on what you've seen here at Fyuz, the conversations you've had both during the conference and on the sidelines, I'm curious what strikes you as innovative that kind of fits into the mold that you both described. To recap, this morning in the innovation-focused content stream, we've talked about the RAN intelligent controller, XACs, RX, advancements in silicon, both x86 and on ARM, neutral host models, et cetera. So just what stands out to you, Canis?
Mm-hmm. Yeah, I mean, it's the venue that stands out to me the most. It's really awe-inspiring, and the people who I meet or who I met, it used to be that TIP and other telco events were mostly traditional type of people, like traditional vendors, telco focused. But this time, I see I'm really impressed by the breadth and of the scope that we're taking on. From, of course, the well-established programs that we have on Open Wi-Fi, Open RAN, Open OLT. Very, very pleased to see the progress maturing into the next step of their life cycle, getting closer to deployment. Extremely, extremely refreshing. But then what's even more refreshing is the new focus that we're taking on, how we are going beyond our comfort zone, getting into, as you mentioned, Rick, the RApps and XApps, creating monetization opportunities for the telco, as well as the ecosystem around us. So yeah, super inspiring.
Anything stand out to you?
I would echo what Canis just said. I think that maybe I would also stress the focus. If I try to compare last year and this year, I think this year I really see a focus, very strong focus, especially on how we can address some hard topics. We see in the conversation, for instance, different options to address L1 acceleration. There are different architectures, and it's extremely refreshing to see the pros and cons of the different views. And many of the discussion I had were very focused on that. Then there is also, of course, the question of automation. There is a very strong expectation of automation of the RAN in the future. And everything that we are trying to address with both non-real-time but also near real-time will be so enormous in terms of innovation. I really like this place because this is really where it happens.
You mentioned Fyuz last year, and if I think further back to TIP events from the past, you know, the hesitancy to me seems like it has faded away, and now the message that I've heard at least is operational readiness, but I'm curious to see how you all are gauging this. Canis?
Yeah, so operational readiness is going to be the next big challenge that all of us, each one of us are facing. And I do see TIP specifically playing a very, very vital role in helping us go over that hump. So any disaggregation, any programmability is just talk unless we are able to re-aggregate and able to reprogram the systems. And this re-aggregation and programming of the system requires meeting of the minds, and I literally mean meeting of the minds. And I see TIP as the connector that connects the various suppliers who will be participating in this broader open ecosystem, and then bringing them to a place where we can actually do experimentation, real-world experimentation. So multi-carrier labs would be, in my opinion, crucial to the success of open anything, be it open Wi-Fi, open RAN, blah, blah, blah. Unless Laurent and I and some others are coming together, creating a win-win in a lab for all of us, I don't see how any of us can succeed. And TIP is the right place to do that, and they are doing all the right things. I mean, bringing in Amanda Toman, for example, into this mix, and bringing in the North American operators to Fyuz, which have been outside of Fyuz, already is a testament that we are going beyond our comfort zone and bringing the right players to make things happen. And I'm super proud of TIP for doing that.
Laurent, how are you feeling? Are you feeling confident? And to Canis's point about multi-operator collaboration, where do you see that going?
Oh, definitely, I'm confident, and I would like to come back on the focus I could feel this year. And I think the focus is really operational readiness. There were a few announcements, and I would like to point out a few announcements this week, which I believe show that operational readiness now is really there. So there were the NTT Docomo announcement about the RX platform, which is quite impressive, and I think it will be extremely useful for the industry. There is also the Ericsson announcement about the Million Radio, which are already Open RAN compatible. There is a Vodafone announcement about their future massive RFP, very impressive. We have, by the way, a common announcement together with Vodafone about the fact that we've started an Open RAN deployment in a RAN sharing mode in Romania, and it's live now, and we have the first calls which happened last week, so it's impressive. For us, it's a very important milestone. And I think it's not just about Open RAN, it's also, I would like to mention that in Orange, we have also a big program on our international backbone, fixed backbone, and we want to disaggregate the full infrastructure. And we've started already this year, and this is live, with switches. And our goal is to go also with P routers and PE routers later on. So it's a big program, very important, and we leverage TIP for that.
Let's switch gears a little bit and talk about artificial intelligence for a moment. I'd like to understand how this is fitting into your short-term thinking at your respective operations. And beyond just the rosy, positive outlook that we all may prefer to focus on, is there anything that gives you pause, gives you concern, that you think we are going to have to collectively sort through? Kanice?
Yeah, AI is a topic that excites me the most, and it has been exciting me for many, many years now, so it's nothing new. Deutsche Telekom, my employer, we have been using machine learning and analytics for many years for operational efficiencies, customer experiences, I mean, the normal things that anyone would do. But what is even more exciting these days with the advent of LLM is that how it is bridging the gap between the human intelligence and the machine intelligence. And then when you create that interface between the human and the machine, the possibilities that it opens up are endless, limitless. And I'm truly excited about that. So we've had many conversations on AI, specifically here at Fyuz, not just any other typical use case discussion on AI, but what are the, I mean, this is basically taking me to the question on what makes me pause. What makes me pause is basically, yes, the opportunistic use of AI, sorry for my losing my tongue, is there. Use case driven is there. So we pick a use case, we get the data, we solve the use case. But it's about time that we start to take a holistic look on how do I create the AI machinery that is evolving and optimizing not just my operations, but also is evolving me and the customer base along with me and the society. And there, really, I mean, there are some very key hurdles. The biggest hurdle that I see is data. So data is the lifeblood of AI. And who else is in a better place to do data than us? Because we are the closest to humanity. We are the closest to the customer, the human beings. But the irony there is that we don't build our own tech most of the times. So we buy equipment from the suppliers, and these are black boxes. And the data is hidden in these black boxes. Yes, there has been a lot of push, like Lauren mentioned, on API, on exposure of capabilities. But these are data which has been filtered, and it has been wrapped in many, many envelopes. So the actual intelligence hidden in the data is still invisible to me. And unless I'm able to unravel that intelligence, I'm not going to be able to make use of it to optimize and modernize and monetize my network. And that's where the conversation will be, or the next few conversations will be, within TIP and in the other communities. So we've had a breakout yesterday specifically to discuss what are the complex challenges that we as a community can solve. And more news to come on that aspect, but I'm super thrilled and super excited to be working with my colleagues and partners to help unravel some of those complexities.
Yeah, there's a number of interesting dimensions there that you described, Laurent. How are you thinking about sort of the focus you need to maintain on your customers as you leverage that data to ideally help your own business while also helping them enjoy the network and experiences that ride on it better? But just, it is complicated, but in brief, what are you thinking?
Yes, so I think there are plenty of areas where AI will be extremely useful, and it is already the case. There are some areas where It's more about customer value management, more on the marketing side, how we can, for instance, implement in the right way the next best offer or the next best action in front of customers. It's also about how we can help our contact centers to be much more efficient in front of customers. But there are also some extremely interesting use cases also that we are deploying step by step on the network space for our customers, for the quality of service, and for the quality of experience. So typically, one of them is around anomaly detection and how we can, for instance, address in a way which is almost predictive, even in some cases predictive, issues related to some quality of experience or quality of service problems on the voice, for instance. Voice, if you consider voice, the problems can happen in different places on the network side. It can happen on the core, it can happen on the transport layer, it can happen also on the RAN, and you need to understand in which radio sites and so on. So with AI, you are able, and this is something that we've done, you are able to identify the root cause in just maybe 2 or 3 minutes instead of several hours. And this is something that we've deployed, and we are deploying that in many countries now. Now, coming back to the question of hurdles, I completely agree with what Kenny said. It's not really a question of pause. I wouldn't say it's a pause. It's more a question of how we take care and we make sure that we look at all the aspects which are important for our customers. GDPR in Europe is extremely important. So privacy is very important. It's at the center of the way we implement our data foundations. Second, it's about ethical aspects. We've also created an ethical council to address all the questions related to, for instance, how you explain an algorithm, how you make it transparent. Then there is the most important hurdle for me is exactly what you said. It's not AI, it's data. It's how you make data accessible to all the developers, data scientists, in a way which is extremely easy to consume. And this is 95% of the problem. It's not AI the problem. The problem is how we get this data layer. We call that data democracy. Data democracy, we have a data democracy program, and it's really in the foundation. And we cannot do that alone. We have to do that with all our partners. As you say, with black boxes, it's extremely difficult. So openness is very important, but it's also how we can bring that to the data lakes in a way which is easy to consume.
So if we think about the topics here at Fyuz and the focus on hardware-software disaggregation and the various network domains, and then kind of expand that to look at some of the other trends that are really reshaping mobile at the moment, I would specifically call out distributed cloud with a hybrid cloud environment, the management complexities that come with that. I wonder when we get into this new world where there's all types of new people, processes, and workflows that need to be built into these organizations, do you feel like operators are generally prepared to be successful in this world? Kenise?
Definitely. So the distributed world is an operator world. The telecommunications networks are the most complex distributed applications that can be. We know how to run and operate them. It's just that the telco networks and the cloud has evolved to a point where the differentiation between a traditional IT app and a telco app is getting smaller and smaller, which is a good thing. It's a good thing that it gives us the more flexibility and more agility to be able to evolve and grow and deploy our networks. But it is also opening up door for other players to come and partner with us to make the ecosystem much broader. It's going to be the edge, or what I call the distributed edge, because the edge is nowhere. You can just drop compute anywhere you need it, and that becomes your edge. And as the edge gets distributed, the more it gets distributed, the more complex it gets in terms of the ecosystem that you need to make it successful. So it has to be a win-win. I, as a telco alone, cannot do it. The cloud providers who are mostly running centralized business models, commodity-driven approaches, they alone, although they know compute the best, they alone cannot do it. And the connectivity providers who are in the business of creating on-ramps, cloud on-ramps, cannot do it. We need all of them together in the win-win marketplace. Yeah, so we are super excited about this hybrid space that is being created, but then along with every opportunity comes threats and challenges, and we are going to be taking them head on.
Certainly a very dynamic market in terms of the partnerships that you need to be successful. So Laurent, how are you thinking about this if you need to distribute intelligence right out to your own edge at your radio site or to your customer's edge at their location? Just what's sort of the logic that's applied there, and any concerns you might have about fully capitalizing on this new world?
So it addresses several aspects. I really like what Kenny said, and she's very positive and optimistic. I'm in as well. I think there is an opportunity, a huge opportunity for us to platform our core business and to make it really complementary to what hyperscalers are doing in their own business, and consider the network not as a dump pipe, but really as a very rich platform, which together can be combined. If we want to do that, I think we need to look at also the journey, and the journey is very important. On the network side, there is a culture which is evolving, and step by step, I think network people will, to some extent, will be very similar to IT people, and they will use and reuse some of the practices, and it has already started. And I think it's important that we keep that kind of blurring interfaces, and maybe at some point things will converge on the same platform. What we try to do, if I take the example of Orange, with a bold objective by 2025, is to reach level 4 in terms of automation according to the TM Forum scale of automation of networks, autonomy of networks. Level 4 in 2 big processes. One is change, which include everything related to CI/CD, DevOps, DevSecOps of the network. And then there is everything related to monitoring of the network, using AI and so on. On these 2 parts, we really tried to be extremely focused and reach level 4. I think it's not enough, and we need, in addition to that, really to work on how we can monetize and how we can expose those capabilities on top. And this is not easy, because as a telco, we are not used to work with external developers at scale. And this is potentially also a space where we need to find the good sauce and the good alchemy together with our friends on the hyperscaler side, but in a way where it's a win-win collaboration.
What does all this mean for TIP as an organization when we think about this expanding aperture beyond just a programmable network, but a programmable network that's deployed in many clouds in many places and is tuned to the specific needs of a client as they arrive at those needs? What does it look like for TIP?
TIP is sitting on a very opportune moment at this time. TIP, as I said, I see the TIP as the connector that brings all the right parties at the right time in the right place to solve that complex problem that requires all of us. So I'm super excited about the future ahead and the role that we are about to play in this space.
Laurent?
Yes, I think TIP has a very important role to address the new level of complexity that we have to face. We have to disaggregate our infrastructure, our networks, on the different network segments, and this is a very important move. We have to become much more cloud native in the way we address our operating model and so on. By the way, I think something I would like to stress also, we've just issued a manifesto together with NGMN, showing that together operators really think the same way how we need to transform ourselves. And I think it's very complementary with what TIP can provide. TIP is very good at addressing the integration complexity of this new world. TIP can provide the badging and the certification of blueprints. And this is extremely powerful because if we redo that every time all over, I mean, the CSPs, the telcos, and so on, it's useless. So we can really mutualize this capacity.
So I think I've got time for one more question. Naturally, I've saved the most complex one for when there's a limited amount of time to answer it. But if we think about this sort of long arc of telco, this continuously pressing need to return to growth, to get away from stagnation in ARPU and ARPA, you know, this requires capital, it requires more energy, it requires more resources, which is somewhat antithetical to the economic conditions and to the environment, the physical world that we live in. So I'm just wondering, when you think about innovation, your responsibility to humanity and your role at your organization, where's that intersection between innovation and sustainability? What's going to happen?
That's a very, very heavy question to address in 2 minutes. So yeah, I mean, as compute gets closer to me and it gets ingrained in my daily life, at a certain time in future I may be even inhaling compute. The question that you raise of sustainability, equity becomes paramount. It doesn't remain to be a side conversation anymore. It has to be ingrained in the DNA, in the roadmap as I build tech. So yeah, so I'm not concerned about the new technologies that we're creating, because that is going to be the case. The security, equity, sustainability, energy footprint, carbon footprint, all of those would be the key KPIs in the tech that we build, and that's how we are shaping those techs. What worries me a bit more is the things which are running in operations at this time. The things which were not designed with carbon footprint in mind, things which were not designed with energy efficiency in mind. How to solve those problems, maybe a conversation we can have at a later time.
And I mean, yeah, last word here to you, Laurent, but it seems like the only solution is innovation. That is the only way out of this, and it's just a matter of getting the time horizons correct. But just what do you think? Definitely,
definitely, I think it's very, very hard problems. I mean, as a citizen like all of us, it's really amazing to see that in your life, you see really every day the impact of the climate change. And in your professional life, I mean, the first goal that you need to have is really to see what are the options. And you address several dimensions. All the dimensions regarding sustainability are very important. I would like to really to stress the CO2 one. And I can say that in Orange, there was a huge awareness growth in the past few years. So CO2 was already very important in the past, more in terms of the way we manage energy, our scope 1, scope 2, energy consumption, and so on. Now the new dimension is that we really understand that scope 3 and the way we are working with our partners is extremely important. So it's really an ecosystem question, how we can make sure that the full life cycle of all the equipments, and not only for CO2, but also for the way we manage and address some metals, precious metals, or precious materials, like rare earths or other materials, and so on. We really need to think of that in a way which is an ecosystem, and how we can recycle, how we can make it circular much more than before. Which means that there are also some trade-offs. We cannot think of the new G technologies as before, where we bring a lot of hardware, new hardware, every time. It's not sustainable. We need to think of it also in a more software-oriented way. And by the way, I'd like to say that we've just issued an important statement with NGMN, which is how we see 6G and how we should address 6G. And I think this is important also to really think about our future in a sustainable way.
We'll have to end it there, but thank you both so much for your time, for your perspective. Let's have a round of applause for Kanis and Laurent.
Ladies and gentlemen, please welcome Christian Toivo, the Executive Director of Telecom Infra Project.
Okay. So, what an event, and I see some people leaving. Please go to the breakouts. They will continue, and I will repeat it still at the end. The breakouts will still run this afternoon. What a great event. Nothing more I can say in terms of adding to what Kanis and Laurent and Sean shared on their reflections. The event is made up by all of us, all of you, more than 1,200 registered participants through the door, 45 exhibitors and sponsors from 47 different countries. Pretty amazing. I think I've seen meetings, momentum, discussions, and probably business being done on the side, which is why we are all and why you're all here. So really appreciate fantastic achievement. We also are in full planning for Fyuz 24. We'll come back later. We'll be back, as Arnold Schwarzenegger said in Terminator. With that said, I would just want to say, take it, use it all the way to the end, keep innovating, and of course, once we are finished here, travel safe back home and see you soon. Thank you.